We live. We live, we live, we live. Alright. Let's go tell everyone to get in here. Let's go tell everyone to get in here. Boom. What up, Blades? What is up? What is up? What is up? What is up? What is down? What is down, 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 down? Nice. What's up, Cap? Oh, AD. What's up, AD? Good evening, Flame. Good evening. Welcome. Welcome, 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 welcome. How are we all doing today? How are we all doing on this wonderful day? Hello from India. Hello from Boulder, Colorado. Hello, hello. Wait, can we test stream delay real quick? I realized that since I don't know how things work, I changed it so I think it's less latency now. I'm gonna say a word in a second. Actually, I'm just gonna say now, and when I say now, immediately get ready to type when you hear me say that, so I can tell like how long the delay is. Okay, ready? Now. Okay. Okay, cool, cool, cool. That's less. That's less. That's definitely less. That's definitely less latency. That's totally less. Is this, what is going on in the chat? It's like, you got that gray line there. Maybe I can do this. There. There. That's better. I learned how to crop things. I didn't know how to crop something, any overlay. So we did that. I think for next stream, we're gonna try to dual stream it on YouTube and Twitch. I think starting next stream. I said I was gonna do that last time. Last time I was like, I'm gonna do it for this time, but then I was traveling and I didn't have time. I was extremely tired yesterday, and I could only will myself to do so much, and then I didn't have time before the stream started to get it set up. I have like a bunch of plugins and stuff set up now to do it. I probably only needed like another half hour, but I didn't really want to delay doing the stream by another half hour. So I kind of just sent it. We kind of just went for it. Yo! How you guys doing? How's everyone doing today? What is our what's everyone's favorite food? We gotta talk about the important stuff. Give me a strong opinion. Give me like, I love this food, and not many other people do, but I love it. Let's have a debate. Pasta? Yeah. I mean, I feel we gotta be a little more specific on that. Like, what kind of pasta are we talking about? What are we talking about with that? For me, it's a bolognese. I love me a good bolognese. That's what I like to eat. McDonald's fries with ice cream are so good. Anyone that is like, I don't like fries with my ice cream, or like, why would you dip your fries in ice cream? So I've brought that up to people. I'm like, oh, we gotta get fries if we're getting ice cream, so we can dip the fries in there. And they look at me like I'm crazy. I'm like, what? Who? Like, why would you not do that? Why, if you were gonna do fries, why would you not put the fries in the ice cream? You never tried that, AD? Dude, it's so good. It's so good. Are any of us real? Probably not. Pizza. When you say pizza, do you mean like just cheese pizza? Because I vibe with the cheese pizza. But maybe at least like a margarita. Or at least like a margarita pizza. basic tomato sauce. Just like a marinara. I mean, that's fair. Pizza with pineapple? Uh-oh. Some people might get really mad at pizza with pineapple. Some people are gonna get really, 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 really mad at that. Some people are gonna look at you and be like, that is the most disgusting thing I've ever heard in my entire life. And someone here might support you and be like, I'm the one other person here that's with you. It's not gonna be me. Will not be me. Burger King Whopper. Oh, hey Arnav. Arnav, you're gonna take my when our surprise guest gets here, you're gonna take the thumbnail. I need you to take the thumbnail screenshot again. When I go out, and you just like, I just need you to like take the thumbnail for me again. Wait, putting fries like what do you mean like putting fries in your like you dip the fries in the ice cream? Yeah, you like dip the fries in the ice cream. Like you have your ice cream and like, or sometimes you like, you do eat them together. Like, it's hard because the fries, especially McDonald's, are like very limp. So you kind of just scoop ice cream, fry, and eat it. That's kind of like the way we go. But but we got something cool today. We got something cool for the stream today. As I mentioned, for anyone who's new here, next time I'm going to try to do the dual YouTube Twitch. I feel like streaming on Twitch I feel like that's a better like community platform for people to ask questions and do stuff like that. So, but YouTube's good because I can leave the VOD up so people can see it after, because I'm not trying to gatekeep anything and be like, oh, you have to be there to see things. And I also don't have the raw manpower to clip everything from streams and put it into a channel. I also don't have enough people unsubscribed to the channel yet where it's worth making a clips channel for anything. But yeah, we're gonna do a little Q&A to start. But today here's the general premise of what do I follow F1? Ooh, we're sidetracking real quick. So we'll get back to this is the ADHD kicking in. We're talking about F1 now. I do follow F1. I love F1. You may have been able to guess that by the attire that I'm wearing. I got my Senna shirt on today. So I do follow F1. I'm a Ferrari fan. So basically, I'm depressed is kind of the premise of that. That's kind of the takeaway we can get from that. But I do follow F1. I love F1. I'm trying to get one of my roommates into it right now. I'm trying to show him Drive to Survive and get him behind F1, because that's how I got into it. I watched Drive to Survive and I was like, oh my god, there's so much stuff going on behind the scenes. It's as much of like a engineering competition as it is just a competition of racing. Depression is constant, yeah. But I got Ferrari merch and I also have McLaren merch. I don't mind McLaren, even though they're English. But yeah, we'll do a little Q&A in a second. But here's the general premise for what we're gonna do for stream today. So we're gonna do a little Q&A just for a little bit, and then what we're going to do is we have a in-person guest that's gonna come in on the stream in a little bit, and they are going to be talking about some of their research in theoretical quantum physics. Yeah, we got a theorist in here. So when the theorist gets here, we all have to make fun of him because he's a theorist and I'm an experimentalist. That's kind of how we have to go around about things here. So yeah, that's gonna be really cool. We're gonna talk to a theorist on his research in theoretical physics, kind of like what's that life about? We're also gonna talk about like how did they get into research? How did you figure out this is something you want to do? How can you build yourself from a point of I barely know Calc 1 to I'm doing research at an extremely high level and I somehow understand some kind of math now. That's kind of what we're going for this discussion. It's gonna be cool. And instead of last time where it was someone over a call, they're gonna be sitting. Where I get a chair? That's a bad host of me, isn't it? That's a pretty bad host. I'm gonna be like, yeah, just sit on my bed. You're just gonna sit right there. I'm gonna have to like move the mic So it picks up both of us. Yeah, it's a very jank setup. I don't got that professional. I don't got two Shure mics right here where both people can talk into them. Get it? Yeah, we'll get a chair when they get here, I guess. We'll get a chair. But until then, until they're ready, we're gonna do some Q&A. So feel free to rifle questions out. Feel free to rifle some questions. I see one question that says, thinking of studying physics at my university, follows old Soviet Union curriculum. What do you think about that? I don't know what the old Soviet Union curriculum is, but I'm very interested to hear what that is. Like, what is the old Soviet Union curriculum? Huh. That's fascinating. Anyone here know? I mean, I gotta admit, like, a lot of physics is pretty standardized. It's like one of the most standardized things around the world. I have international friends who are able to come in to the US and work just fine with people from the US, and same vice versa. So I want to think it's fine. Is it worth doing a PhD? Depends what you want to do. If you want to do research and you really, really want to do like research, then yes, it can be worth it. I think the big advice that I try to give people is that if you're at a point where you're like, I don't know if I want to do a PhD, it's on my radar though, then if you're an undergrad or even high school, think to yourself, what do I need to do to get into a PhD program? Because if you do that, I have a video on this too. If I give every student one piece of advice, it would be this. It's that video. But essentially, what I did is I don't know if I want to do a PhD yet when I'm an undergrad, but I want to leave that option on the table, but also not close my doors off to anything else. So what I did is I went, okay, I'm going to pretend I want to get a PhD. Think, what do I have to do for that? What is everything I have to do to get a PhD? And when I did that, I then was like, okay, I'm going to join a club. I'm going to go get research. I'm going to try to publish papers. I'm going to do all that kind of stuff. And when I got to the end of my undergrad, after the long array of things I did, it's called covered in that video, then what happened was I was like, oh, wait a minute. Now I'm qualified for a PhD if I want to do that. I'm also qualified to do a master's if I want to do that. And I have a really good resume and I can go get a job if I want to do that. Oh, sneeze time. Yeah, I'm muted. Everyone gets mad. People get mad. But yeah, that was my kind of thing. If you don't know you want to do a PhD, then pretend you do. And think what you have to do for that. And that's going to qualify you nicely for a lot of other things that you want to do. Whether you want to actually do it in the end or not. You're funny? You're funny. No, you're funny. I don't know if you're funny, but I'm going to assume you are. Because your profile picture is... Never mind. I can't tell what that is. Do any grad students with a stutter? If so, how do they manage giving talks? Word it might in fact... Oh. Perfectly. There's so many... Don't let any kind of thing like that stop you. No one... What matters, especially when you give technical talks, is what matters to give is the content in it. People aren't going to be like, oh, he didn't give that off perfectly. I can't believe it. They're going to be like, wow, that was really impressive research. They're not going to care that you have a stutter. I promise you. They're not going to care what your voice sounds like or anything. You should not let that limit you at all or let that concern you at all. There's absolutely no judgment anywhere here. If I saw someone make comments about giving a talk with a stutter and be like, oh, they sound weird, I'd be like, shut up. I'd be like, that was really cool work. What are you talking about? So yeah, there's you should not let that stop you. You should absolutely not let that stop you. I am funny. It's from Baku, dude. I used to love Bakugan. I used to get like what was the OG like dragon one, that ball? It was like the OG dragon, like it's literally not Dragon Ball, like the show, like Dragon Ball. I got like a little mat, and I would like chuck it on the mat. I never even played it. I never even knew how to play Bakugan. I just thought it was cool that you can get these little things in a ball, and then when the magnet like hit the thing, it like popped open, and I would just throw it. Like I would just like walk around my house and just chuck it at stuff. I never knew how to play the actual game. I couldn't tell you how to play it. I just loved the little things, and I had a bunch of them that I would just throw around. It was like that, and like it It was like there was an arc of like Bakugan. There was the Beyblade arc still goes hard. I would still run some Beyblade. Someone put some Beyblades in front of me and we're gonna run it today. I'd let it rip. That's all I gotta say. I would definitely let it rip. And then there's a Pokemon arc which always comes and goes in waves. We love Pokemon, but I remember getting cards as a kid and then like sitting with friends and we would just sit in a circle for hours and just go through the cards that we all knew we had at this point, and we would just talk about trades that we would never execute, and then that was kind of that sums up my childhood. Anyways, let's grab another question. I failed math and physics exams and I have a year left until the next one. I got into electrical engineering. Your videos are helping. I'm glad they're helping. I will keep making more stuff that keeps helping you. And if people ever have ideas of things that would love for me to talk about, please put them in the comments. So then I can make note of these things. Doesn't mean I'll make them right away, but I'm going to keep these things in mind. I'm going to make them for the future. How would you deal with an underfunded physics department? The only long-term research we seem to have is with the national lab and the army. If you were talking as like a grad student, you shouldn't do a PhD with the lab if they can't fund you. Simple as that. But the advantage doing a PhD, now I'm going to pretend you're in the US because, oh wait, now you said national lab, so I'm going to imagine you mean the US. The advantage of doing a PhD is you don't have to worry as much financially about where you're going school-wise because they pay for you to go do a PhD rather than paying. So it's not like you have to be like, that school's too expensive for me. They're going to pay you. Your tuition's going to be paid for, and then you're going to get money on top of that to live life. And that'll get you through things. So if you're stuck in that situation right now and you're like, how do I deal with that, and you're an undergrad, then undergrad research, I wouldn't expect getting paid for undergrad research, so I wouldn't think too hard about that of like getting money. Yes, it's nice, but like you shouldn't really expect it for undergrad research. And then if the lab is struggling to produce work, either maybe or underfunded department, I mean, there's still research that goes on, even if they don't have a ton of funding. They might just not have. Usually, a lot of the funding is to like pay you. You can even look towards theoretical research. You can maybe look towards theory, because theory requires no money, and that's why a lot of theoretical PhD students tend to TA for a lot of their PhD. They tend to have to teach classes because they can't get funding under their lab immediately. But there's ways to work around it. If you have more questions, like hit me up in the Discord too. If you're like actually really struggling with that, feel free to shoot me a message. Can I ask you a question? Of course, yeah, you can. Yeah, you can. No, you specifically, you can't ask a question because you asked if you can ask a question. You can't. I'm kidding. No, ask a question. Of course, ask a question. Here to answer it. Explains singularity like you would to a 5-year-old. Think of a golf ball. Now, what if I took a golf ball and I got a lot of golf balls together? And now, what if I took all those golf balls and I squished them into one golf ball? And then what if I took that golf ball that I squished into one golf ball and I put more golf balls around it? And then I took all those golf balls and I squished them into a golf ball again. And then I took more golf balls and I put them around that golf ball that I just squished from the other golf ball that I squished from golf balls. And now I squished all those golf balls together. And then I got another set of golf balls and I put those around that golf ball and I squished them all around that golf ball, which I squished from other golf balls, which got squished from other golf balls from golf balls. And then squish that together into a tiny place that you can't see, like a speck of dust. Singularity. I think that was probably the simplest way I can describe it. I'm sure everyone understood what I just said. I'm sure that made a lot of sense. When did you have an aha moment in EE and physics? Whatever that means to you. When I graduated. I'm kidding. No. An aha moment. I feel like it's usually like, oh, I'm taking intro quantum mechanics, and then I now think of something that I did in intro physics, and I was like, oh, that's why that happened. It's usually always like when I take the next class, then I look back on the class that was one level below it, and I'm like, oh, that was why they did that. It's always like I have to get to the next level and struggle at that to make the level below it make sense. It's always like I have an understanding of one level below, but then the level I'm currently at never makes sense. That's kind of like how I feel. I think the 5-year-old just throws the golf ball. Yeah, I think because now I packed like a really big golf ball, and I think he's gonna just throw it at me. Golf ball? I didn't say golf ball. I said golf ball. You're dumb. You're stupid. No one likes you. I can say that to you. Nobody likes you, Arnav. Nobody likes you. Everyone thinks you're dumb. Anyways, which courses that physics majors take and nuclear engineering don't take? Oh, also, if anyone's new here, sorry, Tide Dirt. Soon, we're doing a little Q&A kind of right now. We're doing a little Q&A kind of just like chatting until our guest is ready. And then he will be coming and sitting on my bed, or maybe I get a chair. And then, yes, no one likes you. I know who you are, Gravity Switch. I know who you are. Just take your damn no, we gotta wait till the guest gets here, and then we'll take the thumbnail pic. But when he's a student in theoretical physics, he does a lot of research in quantum. So we're gonna talk to him about some of his research, and have some good yaps about how he got into research, how you can get to doing theoretical research if people are interested in doing something like that. And yeah, it'll be a good conversation soon. But just waiting, I assume, for a random knock on my door. And then we'll get that going. But for right now, until then, we're just yapping to a little Q&A. But let's grab another question. What do you think about the theory that says our universe is inside a black hole? I think there's a lot of theories that say a lot of things that have a lot of math that make a lot of assumptions. And in the end, it's really just like, you can kind of break it all down like it's a golf ball, that you put more golf balls around it, and then you kind of squish those golf balls together. And then you put more golf balls around that, and then you take those golf balls and you squish those golf balls around that golf ball that was squished from other golf balls. And then you take, what's the next step? Oh yeah, more golf balls, and you put those around that golf. You get what I'm going. You get what I'm getting at. Is a physics degree worth it on bachelor's degree only? It can be still. I mean, a lot of the times, usually people that will end with a physics degree and just a bachelor's will work engineering jobs. I have some friends that graduated with just a bachelor's, and they ended up going to get a job in something more engineering related, and now they're looking towards more grad programs funded by the companies they work for in more engineering related things. So that tends to be how that goes. What do I got? What's this? Oh, I got this still on. Turn that off. We don't need the magic smoke. I'll be doing basic physics. Can you give me some advice? I want to do HEP. What is HEP? High energy physics. Spend a lot of time reading the book. It's gonna be hard. Understand it's gonna make no sense, and it's gonna be tough, but you kind of just have to stick through it. You just keep going. It'll never make sense. You'll never feel like you know what you're doing. I don't know what I'm doing, but somehow you look back at some point, and you're like, maybe I know something now. Like, just maybe I know like one of those things now. Whose account name is YouTube account? How do you even get can you just make your name whatever you want? How do you get the name YouTube account? How do you even do that? I assume you just said it, but like, why do you make a YouTube account? That's like putting your password as password. It's like, duh. Maybe we just live in one. Yeah, I think we do live in one big golf ball. I always knew it was balls all the way down. Yep, it's really just all balls. A lot of balls. What is the wave collapse function? The Schrodinger equation? You're talking about like, what is a wave function? It's under measurement. A wave function collapse under a measurement. Not like a, I don't know how to like put, I don't know if it's like a function. Yeah, it's like an operator. I guess to say, like, if I put my position operator on my wave function, then I'm performing a position measurement, and I can collapse that function. That wave function. That wave. I think we're on the same page. Anyways, you think fusion is ever gonna work? I mean, fusion is much better than SolidWorks. No one really likes SolidWorks to make CAD designs. So there's a lot of people here that I think have used SolidWorks, and they would be like, I hate SolidWorks. But if you go to Fusion 360, then you're gonna be like, wow, everything is so much prettier and definitely better to CAD stuff in. Was that not what you were asking? Definitely not. You think fusion is ever actually going to work? Let's try that again. Yeah, I think it'll work at some point. Just kind of like a lot of research that takes a lot of time to do. Takes a lot of time. I don't know when it'll work. I don't think it'll be soon. But I bet they get it someday. Hermitian operator jump scare. Wait till I give you the non-Hermitian operator. Does ER equal EPR? Are we talking about the EPR paradox? That's a quantum word. ER. Does the emergency room equal the Einstein Vygotsky-Rosen? Was that the name? I think that was the name of the three of the dudes who did that. That's an entanglement thing, quantum entanglement for all my mega nerds out there. Ain't no way Mr. Lemonade Pitcher is talking about. What do you mean lemonade pitcher? See, no one understands what you're saying. Nobody understands what you're talking about, Arnav. Nobody here gets what you're saying. So you know what? What you said doesn't matter. It doesn't make sense. It's irrelevant. No one cares. No one cares about you. Where were we? Nobody likes you. Am I being too mean? I don't think I'm being too mean. What do you think about chemistry? Were you ever interested in chemistry? I always hated chemistry. I have a lot more respect for it now. But like when I was at a high school level and it was like, oh, what science or engineering do I do? Chemistry, I think, was at the bottom of my list. But I'm sure there's a lot of people that would also say that about physics. They'd be like, no chance am I doing physics. They'd be like, absolutely no, there's no planet that I do physics, but I'd like chemistry. I'd be like, good for you. We need someone to do that. That's how I feel about material science. All you people out there that are doing material science, if there are any material scientists in here, speak up because we need you. Because I ain't never touching that shit. I'm never touching that. I will be staying away from that with the 10-foot pole. But we need somebody who likes that. All of you that do that out there, thank you. So I don't have to. What is happening here? Great question. I'm yelling about whatever I want to yell about, and I see in the chat. And then soon we're gonna get a theoretical physics student here who's gonna talk about how he got into theoretical physics, talk about some of his research, and some more yaps. But we're just waiting for him to be ready. And until then, we're yapping. We're just yapping until then. It'll be soon. I assume it's not gonna be more than like. Let's see. But it'll be like very soon. Very, very soon. I assume just like sub 5-10 minutes from my checking. Second year physics student from Engel this year, and I already feel like quitting. Dude, it took you got to your second year before you felt like quitting? Dude, you're doing great. You're doing awesome, dude. I'm proud of you. It took me like 2 weeks. And I was already like, maybe I don't do this. Maybe I just get out of here. But hey, if it took you to your second year and now you feel like quitting, you're doing great. And I'm confident you're gonna get through it. I hate chem from all the atoms in my body. That's true. And from a physics side, we'd say that we hate it from all the quarks because we have to be extra. Can you use quantum entanglement to get information about a black hole without breaking causality? That is too complicated of a question for me to rifle off the dome. No clue. When are you going to switch to data science or machine learning? Oh, bro's hold on. He's calling me. He's coming up here. Hold on. Oh my god, he's so stupid. Oh my god. Guys, when he gets here, we have to make fun of him for what he just did. He's gonna open the door in a second. We have to make fun of him. We have to make fun of him. How many balls can you juggle? Like, what kind? That's a deeper question. If we're talking about, like, golf balls, because we were talking earlier about, like, golf balls and how if you take a golf ball and then you put more golf balls around it and then you squish those golf balls together and then put more golf balls around that and squish those golf balls together from the golf balls made of around the golf ball, and then you squish all of those together, and then we were talking about how then if you 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 put more golf balls around it than if you squish all those together from the golf ball that was made of the golf balls around the golf ball that had more golf balls around. I feel like people are tired of this. I feel like people I can't help it. Once the bit starts, I can't stop. I can't stop the bit. I can't stop it. Lattice. Thank you for saying just lattice. Yeah, what do we just put the golf balls on the lattice? We call it a day. If the speed of light is limited, is possible for a thermodynamic size at the I can't read that. One more mention of golf balls and no, please. No, I promise I'll never do it again. I will never talk about the golf balls that were around. I was just talking about the golf ball that had golf balls around it. We squished it together. Just come in. Open the door.
I don't know why I didn't think about the fact that I.
Oh, you brought a chair. You brought a chair.
I'm well prepared.
Nice.
Oh, it's so nice in your room, Dario.
It is nice and cool having AC. Everybody, he is here. This is So can we talk about first how you messaged me? What room did you think I was?
I thought you were on some Discord call, dude. I was so confused.
What room was I gonna be in?
Well, in my head, you texted me when you're back home.
Yeah.
So I was like, oh, it's gonna be online, you know?
Yeah.
And I never kind of adjusted my beliefs to the fact that you got back.
Get a load of this guy. We're definitely not making fun of. Yeah. Yeah, you knew it'd be him. Yeah, people.
Yes,
some people are remembering your presence from before.
Yeah, when I was trying to go to the hockey game.
Yeah. The last time, for anyone who's here last time when Krish was here, this is Krish also. This is Krish. The last time he was here, he was trying to get me to end the stream because he wanted to go watch.
We were already like 20 minutes late, by the way.
And I was like, yeah, I'll end the stream. I'll end the stream right now. And then I just kept asking questions.
To be a pretty bad hockey game, to be honest.
Yeah. Yeah, it was actually pretty bad. I feel like but then we watched the finals games.
No, I mean in the sense of like the Panthers like destroyed.
The finals.
That was like Chris's house.
Yeah. Anyone here watched the hockey finals and were very disappointed by the Florida Panthers winning? Was that just us? I don't know if anyone else is disappointed by that. But hey, Game 7 NBA tonight.
That's
Are
true.
you excited for that?
I'm excited for that. I really hope the Pacers win.
Are we gonna go watch it somewhere?
I figured Dark Horse, yeah.
Nice.
Yeah.
You can't expose us.
I gotta text the people. But yeah. I guess if
we gotta rally the troops.
Yeah, that's true.
But I think the chances that someone currently in here watching is in Boulder is low.
That'd be pretty crazy.
That would be kind of crazy. But we got a good crowd today. I think people are excited to hear about what's going on.
You labeled this theoretical physicist, which is kind of
that's not misleading.
A lot of pressure, though. I mean,
but it's not misleading. That's what you is that not your title?
I guess. I guess. I don't know if I'm supposed to wait till I get my PhD to call myself that.
Oh, you want to answer this question that you definitely can answer? Can you use quantum entanglement to get information about a black hole without breaking causality?
I actually have no idea.
Yeah, I have no ideality. Yeah. No.
Sorry, I don't know much about black holes.
Yeah.
They're really cool.
But you're a theoretical physicist. You're supposed to know everything.
I don't know. Yeah, I really wouldn't give an informed opinion on that. I think there's something of the singularity breaks information transfer or something, but I don't know too much about it.
Yeah.
Cosmology is not our field, for the record.
There's a big hole. Maybe we can definitely find some cosmology people to. Maybe someone actually knows that. We could talk about
Vimal would maybe know.
Vimal, yeah, we can get Vimal on.
Actually, Vimal would be in condensed matter more.
Yeah, but he just knows random stuff like that.
Graduate do? What jobs can a physics graduate do? Usually there's 3 places people go. Either industry, so stuff like so right now it's really hot and sexy for quantum computing industry to be a thing. Well, in terms of paychecks too, I will say. Which is I have a few group mates who are going to that field, but it's a lot of industry jobs of all these tech companies are we need quantum computing, or all these CS companies are we need quantum computing. So there's one. Or materials people are we need better materials or whatever. Or you go for national labs or NASA, some government funded thing, or you go to academia. And that's what I mean by physics graduates in the sense of getting your PhD. That's where you really go.
Yeah. But let's talk about you.
Oh, okay.
Less about me.
Okay.
Because I talk about myself enough.
Oh,
so,
I know.
I know who you are. I know who you are.
Really? What's my name?
Chris.
Oh,
C-H-R-I-S.
yeah. No, it's actually Christopher.
Christopher.
Yeah.
Christopher. Yeah. But so feel free for people who weren't here last time. Oh wait, yeah, we gotta take the thumbnail. Thank you, Arnav.
Oh my god.
We gotta do the thumbnail, and then we're gonna get right into this. We're gonna get right into it. Wait, I gotta turn the chat off for a second. Okay, we gotta pose.
What is this face you're doing, man? Are you constipated?
You're the one that's doing
You're
that.
doing the. Okay, it's
All right, and then Arnav should have done something with that and sent it, and then dude, did you take it? I don't know if he took it.
Can't you just like have a recording of this and just
No, because you want it up like while the stream's going on. You want to have
Oh, wow.
Because we want to
do
be
it
cool.
again, he said.
Do it again? Oh. Wait, where do you say do it again?
Right here.
Oh. Did you take it? I gotta imagine you got it. I have to imagine you got it. Did you get it?
I'm just staring at Discord now.
This is pre-recorded. You got us. You guys are really good at we plan this out. This is a psychology thing.
See right there? That's a light right there. That window? There's no window there.
There's nothing behind that.
There's
it's just
no
light.
window there.
It's just light.
You think we let Dario see sunlight in this household? Nah.
I've already used up a lot of my sunlight allowance for the month, so
Yeah,
they don't know. They haven't let me out.
No, it's true.
But all right, I don't feel like
quantum computing research. What does that mean, man?
I don't know. My major is heavy on
What does
quantum
that
computing
mean?
research. Is it mostly experimental or theoretical? It could be
Shouldn't
either.
you know your major?
Well, they're
Oh,
learning.
quantum computing research.
Yeah.
It's usually either. I feel like it really depends, right?
I mean, it can be both. Very much be both. I
assume they won't let you touch the fucking cryogenics though. Can I swear on this thing?
What?
I can.
Yeah, I don't
Okay,
care.
okay.
We just had to be within the. I think it's like 10 minutes. You can't swear. And then,
Oh, nice. No, yeah, but like, I assume they want you to touch the cryogenics.
Oh my
too
god.
soon.
Oh my god,
Jesus
Arnav,
Christ,
Arnav, how hard is it? Dude, we gave you one job to take a thumbnail picture. Guys,
You
he's
don't
messing
pay
up.
him, though, to be fair.
I don't pay anybody.
He does have to put up with you too on like a.
Okay, we'll try again. Wait, maybe we should evenly space ourselves a little better.
Okay.
No, I didn't mean get. Okay, whatever. This is fine. Arnav, are you ready? Arnav, I want you to like tell me you're ready this time. Like, I want you to tell me like verbally that you're like, I'm ready to take
He
this.
is on a delay, to be fair.
It's not that much delay.
Oh, okay.
Wait, guys, ready? You show me how little delay it is. I'm gonna say a word. When I say pineapple, not that one. I want you to tell me that you can hear me. We'll see how much delay there is. 3, 2, 1, pineapple.
4 seconds. Oh, Scooter has it. Nice. I can hear you.
Nice.
Oh, okay.
Eight.
So it's like 8 seconds.
Yeah. It's like not bad.
Ah, pineapple. There we go. Okay, cool.
Okay.
Alright.
Okay. Ready? You going? Hold it! You're breaking!
Am I supposed to make a stupid face?
I don't care what you do.
Damn.
We got it.
Okay, there we go.
Why do you have that? It's a funny photo. Guys, we'll upload the photo. You'll see it in a second. All right, hold on. I gotta upload the.
G physics paper. Oh, is that the Indian like examination paper? G physics, or is that something else?
I have no clue.
No, that's something else.
It says IIT G physics paper. I don't know.
Yeah, IIT is
Yeah.
Indian Institute or something.
Yeah.
Technology.
But okay. I'm just gonna
Equals
upload the
17
thumbnail.
squared in one line. How do I prove that? Do you want experiments, or do you want to like me just to write it down?
I think.
Because I could just write it down and make a square. That means QED. What is research in theoretical physics like? Oh, okay. So that's actually a good.
Wait,
question.
we're gonna get to that. That's gonna be what we're talking about. We're gonna talk about that.
To be you, I guess.
That's what we're talking about. That's the point. We're gonna talk about what it's like.
Have you ever heard about the popular? I can't say I have. DreamArts.
Okay, and then save. Boom. Thumbnail
Oh,
uploaded.
dude, the ACs. Wait, you can use your computer and the AC at the same time. You fraud.
Yeah, I fixed it.
You fraud.
Recently.
Jesus Christ.
Yeah, I gaslit.
You
That's
should
a recent.
pay us extra rent.
That's a recent discovery. Huh?
You should pay us extra rent. We're out here boiling. Okay.
It's too late now. We're moving.
No, I can. I'll bring Aaron over right now. Okay, keep going.
Okay. Back here. Boom. All right, let's get into it. So now that their thumbnail catastrophe is done, Krish, feel free to introduce yourself. Talk about like, so what kind of research do you do? Give it like a layman's term overview.
Sure. So I've been doing kind of theory research, I guess, for a little bit now. I started in undergrad, and right now, what I work on. So me and Dario are both in the AMO field of physics.
Atomic, molecular, and optical.
Yeah, we can kind of outline the fields of physics in a little bit, but atomic, molecular, and optical, exactly. So they do a lot of like cold atoms, like specific quantum effects with atoms or whatever. So what I work on is, I think a good way to describe it is that, your GPS, right? You have a GPS or whatever. A lot of GPSs use interferometry, where they use light basically to figure out some really precise signal of how far you are, where you are, this kind of thing, right? So right now, a lot of GPSs or devices use light. Well, what I work on
Could you describe very briefly like how a GPS, like a conventional GPS,
Sure.
like how does that work?
Yeah. That's.
I can answer that.
No. But that's like a.
Like super simple. Like, how do we get? Like, how does your phone have your location?
Yeah. So what usually happens is that effectively, you can think of it very simply, is like you exist on the Earth, right? There's a bunch of satellites in space. That satellite is shooting like light beams to you, and depending on like let's say one satellite is at their equator, one's at the North Pole, right? The amount of distance those light beams travel is different between the two. So they'll like shoot a light at you, get the feedback back, and they'll be like, oh, hey, it's this far apart, therefore we can kind of make some inference of where you are on Earth.
And they use a few different satellites to ping a location.
And also, for the record, super cool, for all that kind of stuff, you need, like, relativity, you need all this stuff. So, people don't appreciate that, right? Like, they're like, what is the practical use of relativity besides, like, cosmology? GPS. You can't have GPS without special relativity, which is pretty cool. So what I work on, though, is, that's all light kind of stuff. I'm trying to do that with atoms. And the benefit is that, like a lot of quantum or atom things, it's a lot more precise. So we can do stuff like gravitational wave finding and that kind of thing, right? We can do stuff like having really precise GPSs. Another big application is that you could use it for space travel. So, right now I told you, right? You're on Earth and you're trying to use a GPS. You need some reference frame, right? You need these satellites floating around. But what if you have no reference frame and you're just like in the deep nothingness of space?
So we're saying now we're taking this thing and what if we mount it? What if we want to put this on a spaceship?
Exactly.
Okay.
Yeah. But there's a lot of applications, basically. As things get more and more precise, you can open up more and more uses for them. But basically, in summary, yeah, that's what I do. I try to basically make atom interferometers, design them, and that kind of thing, among other stuff, or atom devices, I should say. That hopefully, in like a few decades, we can start using them on Earth.
So, in the simplest terms, from my understanding, normal GPS is like I'm on ground, satellites are in space, I'm pinging between them constantly.
Sure.
And I'm using feedback from those signals to understand where my location is.
Sure.
But I'm a reference frame because I'm on Earth and they're in space and we know where they are.
Yeah. Honestly, the analogy kind of breaks down because I mean, like, you can have optical interferometers that don't need a reference frame.
Yeah.
Right. My whole point is that basically right now, for all these really precise devices, we use light, and using atoms can like make it even more precise. And that's kind of what I'm working on, just atom device in general. I worked on lasers, for example, undergraduate. I worked on just junctions. So it's a very similar concept, right? In that case, you have lasers, and they use, for example, in my case, they use regular light. And I was like, what if we put some spin, which is this quantum property in them?
Yeah.
Make them better.
So, so you're trying to make a more sensitive kind of quantum GPS in a way.
Sure.
You can make it. We can dumb it down. We can call it a quantum.
We'll call it a quantum GPS.
But then the technical word would be like an
yeah.
atom interferometer.
Yeah.
I saw the university put out a story on your lab very recently.
That's true.
I did.
Our
I
lab
did
is
see
pretty
that.
cool. So what's also cool about my group, for the record, is that we have both an experimental and a theoretical kind of like side of it.
That was my next question. I was going to say, Chris, this sounds a lot like some experiments are going on. You said you're a theorist. What's going on here?
You're damn right. I'm a big believer in, I like to see my science show up. So like, what's cool in my lab, for the record, is that we also have a lab itself. So this atom interferometer I'm talking about, we're testing it ourselves in the lab, which is super cool. And that's one of the big reasons actually I chose this lab. So for example, right now I'm trying to work on is, like, we have this atom interferometer, right? It uses neutral atoms. So right now it can sense like gravity and whatnot, okay? I'm like, hey, what if we can sense magnetic fields? So we may make a magnometer. So what I'm trying to work on right now is developing a magnometer that they can then hopefully just take my idea and just test it in the lab.
So you're working on the theory, and then you have the benefit where you have people in your lab that are experimentalists,
Yep.
and they can immediately be like, "That's cool. Let's go
Yeah.
try that."
Yeah.
So I guess here's a good question. What would you say is the main difference between doing these things experimentally versus theoretically? Like, what are like they go hand in hand, but what are you doing compared to what the experimentalists are doing?
That's a good question. I'm working on a lot of. I'm kind of trying to give them a route to follow, and then they're gonna like it's kind of like, let's say you're trying to get to a destination, right? I'm the guy drawing the map, and they're the guy making the trail.
That's
That
a
kinda
good
makes
way to
sense,
put it.
right? So like you need to know the route, right? You can't just go to the top of a 14er or whatever and just try to send it. You
Yeah.
need to know roughly the route, but there are still a lot of practical things and a lot of like non-trivial, super hard things of making a trail. You know, you gotta make sure the angle's right so it doesn't like run off waters and like mess up the slope or whatever. A lot of things. And I think that's how I would put it. So in practical terms, I'm making kind of like the algorithm, or like, you know, the procedure we want to do. How do we want to mess with these atoms? What's actually the best way of getting this precision or whatever? And they're gonna actually implement it by like figuring out, hey, how do I actually get this magnetic field to work at this level, whatever, this kind of stuff.
Yeah. What would you say? Another good question on there. What would you say your day to day is like?
That's a that's
Like,
a good question.
I'll just honestly, as a theorist.
I was just looking at Arnav and Scooter's questions.
Yeah, that's also funny. I don't, guys. Arnav. I don't know if Chris might be Indian, but
I don't know.
I don't know if we're gonna be able to figure that one out.
Dario did say my name was Chris earlier.
Yeah,
So.
I think we have to whitewash
Yeah.
him, and he's now Chris.
My day to day is pretty flexible. So this is one of the big reasons I chose theory, is that, and I do want to talk about one point, like how I think theory and experimental compare in terms of like learning curves, because I think
go
that's a
for it.
really cool question.
Yeah.
But like my day to day basically is, I'm a big believer, especially because I'm in the basement right now in this house, of like going into the office and working, because I think it's hard sometimes in theory. So okay, let me see my day to day, then I'll elaborate. I go into the office like 9ish. I just do work at my desk or whatever for so long. Yeah, I'm in a room with my other group mates or whatever, so I can chat. There's a whiteboard there. It's a very chill thing. It's also theory, so I don't like log hours or anything. You know, like it doesn't matter if I work for 8 hours staring at a piece of paper or read it in an hour. You know, what matters is that I get work done. So that's my day to day. I will say I like going to the office specifically because for me, experimental theory. Oh, interesting question. Because it's really easy to work on theory at home. And you kind of don't want to, right? At some point, like, you don't want to always be locked in. It's kind of a lot. So I kind of like having the separation of, like, oh, definitely work on research out here. And I can work on it at home, but I don't need to, kind of thing.
Yeah, because for you, like what I see from you is like if you wanted to, you could most of the time never walk in lab.
Oh, of course, yeah.
And you could just be at home.
Yeah,
I have days where I can go home.
Yeah.
But I have many days where I'm like I have to physically be in my lab.
The only reason I would ever have to actually go in would be to meet with people, right?
Mm.
Or for group meetings or whatever. And that's just because it's nice to have this in person. But yeah. Like, for example, undergrad, right? I was doing undergrad research, so I didn't have to attend group meetings. I was doing theory then. I never attended, like, my desk or anything. I just worked from home. All of undergrad, right? Same for you as well.
Yeah. For anyone who's new here also, since I'm sure we got a bunch of new people in here, this is Krish. He does theoretical physics research. He does a lot of quantum stuff. He works specifically on atom interferometry, so trying to make a GPS, but at the quantum level. So that's probably the dumbest way I can describe it. Someone said you're now Kith.
That's a new one.
Kith.
That's a new one.
I might have to bring that one up to the council.
Nice and simple.
See if we can see that.
Yeah.
Wow, I'm shaking my leg. Shake my camera as I
It's
shake
very
my
close
leg.
to Sith, but you know, I guess I'll take it.
But no, I think that's a very good point to make. And someone said like, what's stopping someone from being an experimentalist or a theorist?
That's a good question.
In physics.
Yeah. So, I think it's okay. It really depends, right? I think. Okay, also, experimentalists still have to do theory. You know what I mean? There's this misconception, and I think really good experimentalists do theory, like, properly, you know?
Yeah.
Like, for example, in my group, our experimentalist, she's freaking brilliant, in my opinion. But she, like, works out Schrodinger's equations. She does theory, you know what I mean? It's just, like, it's nice to have people who are, like, full-time theory to work on more trickier questions of, like, I don't know, figuring out, like, atomic squeezing or some of these fancy things, right? So I think the line starts blurring. What I would say is it's really a case of like, okay, I think it's a thing of time and effort, really. If you have an experiment, you want to kind of just like, first of all, experiments are expensive.
True.
I should start with that, right? They're freaking expensive.
My basic equipment orders are like
thousands.
thousands.
$100,000 or so, at least, right, on an experiment. It's kind of hard for you to be like, okay, I did this one experiment on it that I was designing it for. I'm gonna go like mess off to the whiteboard. you're kind of like, I spent $100,000 on this. Let me like milk this thing for every possible scenario I can think of, right? And that's time. That's just time. And as a theorist, right? Like you're kind of constantly learning. You're getting very deep into these things, and that also takes time and effort, and just thinking about these things. So I think it's just time and effort.
Yo,
you can do both.
Whoever's saying, have you given G? Do you
I
even
have
know?
not.
I don't know what that is.
It's an exam. I'm pretty sure in India. It's like a standards exam.
Oh.
Can you help me with homework? Nah, I'm good.
Can
Man,
you
they're
help?
committed.
Yeah, guys, we don't know what G advanced is. For a person, we don't know that.
Why is Arnav talking to the third person?
Arnav is saying the council agrees that we have to call you Kith.
And what? Is he just the council?
Huh?
Is he just the council?
At least one. You got another council member approving it there too. Yeah, guys. The chat is council. Guys, do we approve of calling Krisha Kith from now on? Do I have to?
One of the funded research internships in my program is optical quantum networks. For the brother, it really depends on what the specific research is. There was a question on some program research internship on optical quantum networks. Is it experimental or theoretical? I assume it's experimental though, for the record.
It's likely experimental. I mean, if I was a gambling man and I had to bet, if someone gave me a blind research project and went, is it experimental or theoretical? I'm putting my money on experimental. Is it is Ali the dazzling server? Yeah, that's the correct link. That's where I also do my stuff. We work together.
Someone says
Fun fact.
I agree with that. There's a question that says Einstein once said imagination is more important than knowledge. Do you have any suggestions on how to get more creative or unhesitating in terms of imagination? I would say I agree with that for the record. You can only compute stuff for so long, right?
Oh wait, I didn't bring the chat back.
Oh nice, okay, cool. So how to get more imaginative or whatever, I think it's just a matter of, I think what a lot of people do sometimes is they focus on like what they're specifically supposed to work on. Like if I'm a quantum computing physicist, right, I'll only read quantum computing stuff. But it turns out that science doesn't really care about our labels on science, right? A good example of this is that right now somebody in my group is working on quantum information and like this whole theory of quantum information thing, right? And our postdoc has a general relativity background, and he's managed to apply that general relativity background to quantum information. But this connection never would have been possible if we didn't have these different fields coinciding. So I guess my suggestion for better imagination would just be, don't focus on the exact task. Sometimes looking into other topics just has links, and that's I think that's how I view imagination. Is just, can you build intuition in different fields where you can start like pattern matching them together?
Yeah, I think that's a great way to put it. Ooh, interesting question. Is quantum entanglement real? Yes, but no, but yes.
That's a very philosophical question.
Yeah.
It's real in the sense that we've scientifically observed it, and if you believe the experiments, then it's real. Is it real in the sense that you think that are you some Einstein kind of guy, and you're like, God, does it play with dice? Who knows? But if you're looking at just the experiment, yeah, it's real, I would say.
I think I was really interested in the discussions in quantum that we had in our last class of how entanglement doesn't break locality. I think it's a very not as mysterious take on how entanglement works. It makes it it's not as mysterious. It's kind of like, no, there can't just be a particle here. We're at one random point, billions of light years away, we find this particle that also is entangled with one on Earth here. It's like, no, those two particles had to be next to each other at some point, and then we kind of move them away in some kind of way.
But, there's just like a ton of philosophical things too.
Yeah.
Where, how bad is physics? Is physics stuck now? I wouldn't say it's stuck now.
I think maybe he means suck. Is just physics? Maybe just take it as.
Or does he mean stuck? I can't. Does
he mean like is the field of all of? Or you mean like is all of physics stuck? I don't know what like. No.
Let me give you a better example for that. Atomic interferometers as a theoretical idea were developed in the 1990s. They're now realized in like actual devices.
That's pretty good pace.
Yeah,
for
and
science.
that's insane pace.
That's pretty good pace for science. I mean, I think we're only accelerating more and more every year in how much science that is being done.
I have not given the International Physics Olympiad. I actually thought about it though in high school. I did Science Olympiad.
How do you get the ideas to draw? Oh, that's a good question. Draw them. Like, how do you get the ideas to draw that map?
Yeah.
Wait, refresh what you just talked about for new people. Just like what you mentioned.
So the way I compared theory and experiment was that the theorist, theoretically, draws a map to a destination, right? underlies kind of the theory behind it, and it's the experimentalist's job to make the actual trail. So how do you get ideas to draw the map? That's actually a very good question. I would say I get ideas by, again, this is just a question of how do you build intuition, right? And this is, I think, one thing which maybe I'll go on a tangent for about experiment versus theory, learning curves. If you just kind of learn enough in the field and read enough papers and talk to enough people, you just start like making guesses, if that makes sense, right? Like, if I see a ball drop 4 times, right, I'm like, that ball's probably gonna drop, from here to the ground, and then I'm like, okay, what if I drop it out the window? It's probably gonna drop from the window to the ground, right? So it's like you build intuition by just learning about stuff and talking to people, and then you just make guesses. You try to work out your guesses, and you're like, okay, was this reasonable or not? And that's kind of how it is. It's to a certain degree is trial and error, but it's trial and error guided by your intuition, which is really your intuition is just guided by all the stuff you learned in the past. Yeah, I'd say that. The tangent I want to go on though is I think it's really interesting, at least in my experience. Theory experiment are really interesting to compare because I view, like, my experience as a theorist, right?
Yeah.
Is that I think there's a harder initial learning curve, but once you get to the point where you're past the curve, it's a lot easier to like get output out, in my opinion. Like, what do I mean by that? I mean, like, usually as a theorist, you spend like the first year or so just reading papers. Like, pretty much reading papers, you know what I mean? Just
I've seen some of your papers,
stuff,
I believe that.
and it's just hard stuff. And, like, for example, to learn atoms from I had to learn, like, Bayesian statistics and, like, all this other stuff, like, how, like, I don't know, AMO does its field, how to, like, handle, like, single quantum states, different Heisenberg pictures, all this stuff, right? But then once you actually get to that intuition, develop that intuition, it's really easy at a certain point just to pick problems and just go with them. Versus experiment, you could point Dario to a lab and be like, hey, look at that device over there. Go fiddle, Yeah, there's quicker feedback on that, right? But once that project is over, you have to kind of like start scratch for a new experiment, right? So there's kind of like bigger turnover, as opposed to theory, where once you build intuition, like I did spin laser stuff in undergrad. I can think of like 4 things I can do a research.
Here, I'll make it shot a little bigger. Let's shift. Actually,
okay,
we're gonna move it. I'm gonna move it to this corner.
Oh, that works. Yeah.
And then we both shift this way.
Okay.
And there we go. We'll do that.
Is math important for physics? Yes, I would say so.
Is math a part of physics? They said.
Important, very important for physics.
Yeah. Wait, this is probably a great time. Can you tell me one of your papers?
One of my papers,
or not? Sorry, papers? One of your labs papers. Show me one of your labs papers.
What do you want right now? Like, what are you savoring? Do you want like an interferometer paper? Do you want just like a scary math paper?
Give me something scary. Give me something scary.
You want something scary?
Give me something. Give me something. I want it to be something that you understand. But when someone looks at it, they're gonna be like, "What am I looking at?"
I have a good one then. Let's do Murray Holland. Oh my god. Oh, dude, your keyboard is like weird.
Do you not like my keyboard?
Yeah, it's just different than mine, right? So here, you want to go back to the.
Oh, my bad.
Murray Holland.
Well, he's doing that for anyone who's new here and trying to figure out what we're doing. This is Krish. He is also a physics PhD student along with me. I do experimental physics. He does theoretical physics. So we're having a conversation about kind of what a theoretical quantum physicist does.
Sorry.
An example of like kind of some of his research.
I think this is a prospects. Oh my god.
Take your time.
Oh my god, man. Are they
Apparently
just, like,
my
different?
keyboard is hard to type on.
Okay, I like this paper a lot. That's one of my favorite papers that Murray's written. Oh my god, please.
Yeah, you're really struggling.
Oh.
I gotta log in.
Dude, that's crazy. You haven't already logged in?
Huh? I don't know if it just didn't say. Oh, wait.
You can try archive too, but yeah, that works.
It's right there.
Oh my god. Oh, you never logged into APS before?
I actually don't know if I've taken a paper from CU from APS yet.
Wow.
Alright, we have the paper up. Let's zoom in on this.
This actually isn't that bad in terms of math, I will say.
But this is like this is a paper,
a really good example in my opinion.
And this is a paper to make it clear that you understand what's going on here.
Oh yeah, of course.
Of course. Sorry.
Of
course, but other people are looking at it.
I didn't mean like that. I meant like, I've read this paper.
Okay, let's switch screens here. Bada bing, bada boom. Okay.
So maybe let me give you a bit of context for this paper. So earlier somebody said, is physics stuck?
Here, take the mouse.
Is physics stuck? And that was a great question. I'm glad somebody asked that question. It's a good question. So this is also a really good thing of what I meant of theory versus experiment. Okay, so my PI is this guy, right? MJ Holland. I actually don't know Murray's last name, but his first name's Murray. Or sorry, I mean a middle name. I should
You
say.
don't know his middle name?
I don't. I should ask him.
I don't know my PI's middle name either.
This is actually I don't know who R. Carlson is or D. Meiser. Actually, I've seen Meiser in other papers.
Yeah.
But Jimmy is also Gila. He's at CU Boulder, and he's like this big experimentalist, right? So this paper was published in 2009. Let me give a bit of background. Okay, so you got lasers, right? And you want to make lasers super precise. Let's say that's our goal, right? And I'm not going to say what precise is right now. I'm just going to say super precise, okay? So you can do like really cool things with them. Turns out, right now you can kind of think of lasers as you have two mirrors and you bounce photons in between, okay? And the mirrors and how stable the mirrors are determines how precise the laser is.
Am I looking at this image here for that, or?
Sure. Yeah, actually, sure. Go up to that image. So, let's say you have... That's actually not what that image means, but we can pretend that's what it means.
Is there a better one?
I don't think so. This is a...
Could we look up a better one?
Just search up laser cavity.
Laser cavity.
Oh, wow. You misspelled it, too.
Yeah, I just typing. All right, pick your favorite.
This is the one I always use.
All right, this is the one. All right, we're explaining how lasers work.
Here, you want to...
Wait, I can
do
just...
a different thing.
Yeah, wait, I could just... Nope, not that.
Not that. Yeah, there we go. Oh, you've done it
Not
again.
that either. Nope.
Brother,
Oh, sorry.
please
Hold on.
drag
No,
it.
I got it. I don't tell me what to do.
No, you can just drag it over. You don't
No,
need to do
don't
this.
tell me what to do. Open.
Why?
Wait.
Please.
Okay, do it.
Give me this.
Okay, do it.
I meant you can just do this. Oh, wait.
Yeah, see?
My fault.
See?
My
See what happened? Oh, you clowning on me?
My fault.
See what happened?
My fault, actually. I guess I'll save it as
Oh, it's an SVG?
Yeah, apparently. Here, you want to open it up?
How do I open up the SV?
Oh.
Okay.
Oh, I did it. Nice.
What do you mean you did it?
I did it. Okay.
All right,
So,
there you go.
a really simple example. You got two mirrors, right? Two mirrors. And usually you can think of photons as bouncing between. You guys can see my mouse. Yeah, hell yeah. And, how precise the laser is how stable these mirrors are. There's this really cool idea.
What does precise of the laser mean?
Okay,
like, very
yeah,
briefly.
Yeah. I didn't really want to get... Okay.
No, it's just super brief.
Precise by laser, I mean that, like, a laser is supposed to be one frequency of light. By precise, I mean how much of the laser is that one frequency of light as opposed to, like, being, like, 1% off that frequency of light.
Can we just dumb that down to... Can we just call it noise?
Sure.
So, just for simplicity.
Okay.
I know what you mean. I know what you're talking
I don't
about.
know if Scott would like that.
I know what you're
term.
talking about.
Yeah.
We're basically laser. We want a certain frequency, and we want to make sure it's as close to that one as we can, and not.
Yeah,
off
it's
of
not
it.
bad actually. It's not
Yeah.
bad because thermal noise adds line width, right? Okay, this is fine. The whole revolutionary idea, right, which some guy named Robert Dickey, had. Which is funny name, guy from Princeton. Had a while back, like in the 1990s or something. I forget when actually. Oh no, way back actually, 50s or something, right? He actually, yeah, or some people in the 70s actually had this idea. They were like, okay, we can exploit this thing called collective motion, and I'm not going to talk too much about that.
I assume not.
Yeah, but basically, we can actually instead kind of shake the mirror, or have the mirrors not be super stable, but kind of like mess with the photons to in fact make the thing stable. It's basically just like flipping the laser concept to get a really precise laser, but it's like a whole new idea of how you do it, right?
So instead of stabilizing this laser, by making the mirrors super perfect distance from each other, we're now intentionally creating some noise.
Yeah, and we're messing with the photons instead in the middle.
And yeah, okay, now the photons are going to be...
Before we cared about is the mirrors, now we care about it is the kind of atoms or the photons.
Okay.
Yeah.
Okay.
So, now back to the paper, which is right
So that's how that works.
So, this paper...
And making a precise laser.
Is Murray kind of being like, hey, I had this idea for this laser.
Murray and Clary is your advisor.
Murray Holland, yeah, exactly, is my PI, my professor. And he was like, this is how the map looks like. It's this image right here, basically.
So this is our map.
This is our map.
Our visual map.
This figure 1 right here.
Okay.
And, hey, if you do this, it turns out we can get... So, before we're talking about precision or noise, right? Precision. Yeah. And let's say before it was at 1, right? Just 1, value 1. We're not
precision of 1?
Yeah.
Okay.
He basically saying, hey, I could figure out this concept of a laser, which would get it to a precision of like, and in this case, the lower number is better for the record. precision of like, or I guess should I go higher?
Well, more precision, so higher.
Okay, we can get to a precision of like 1,000.
So we can make it 1,000 times better.
Exactly, by just
doing
having this map of a laser.
Okay, and obviously, and now to get back to make sure, I'm sure people are looking at this and are like, "What are we talking about? What are we looking at here?" This is what the question was of. The question was, what is like? How do you come up with this kind of map for how you're gonna make things? And a lot of it is kind of these visuals and analogies in the end, and it's kind of like the math builds a picture in your head. Would you say? And you can kind of use the physics to.
The more I view it, it's like you kind of like, so you know, for this laser, right? You have this idea of hey, what if we keep the mirrors kind of shaky and make the atoms really precise, right? And then what Murray basically just did is that he knows all this extra other physics, right? And he was like, okay, how do I fill in the gaps between the shaky mirror to make it into a laser? And then how do I mess with that so it's really a really good laser? So it's almost like knowing a bunch of pieces and connecting the dots.
Okay,
and connecting the dots is the intuition part. That's the imagination part. Is how do you connect the dots effectively?
So he has enough intuition that he went, I know about this thing, I know about this thing, and I know about this thing.
Yeah.
I have enough knowledge of how this works that I'm going to find a way to connect these different things together and create the new thing.
Yeah. And that's what a lot of physicists do, right? You know, I think, Ali, right? Really likes Feynman or whatever.
Yeah.
Right? Feynman was a good example of that. Feynman did particle physics, and then he was like, I just know enough about physics for I'll start doing, like, super fluid physics.
Yeah.
And he was great at it. But that's not his field, right? But he could take the intuition and the random ideas he knew. Like, he famously talks about when Feynman was building the atomic bomb. He's like, I had this, like, random calculus, like, tricks book from, like, high school. And, like, it was really useful, actually, for, like, the mathematical
like
stuff.
Making a bomb?
Yeah. Well, in this term, solving equations. But, you know, whatever. And that's what I really want to get at. I think people have this misconception that you're supposed to, like, just, like, grind your field. No, if you want to do really good science, I think you actually should kind of try to be broad, in my opinion, to a certain extent.
Yeah.
Right? And, like, you never know. It might not be useful for, you know, say even a decade, but maybe you'll come across a problem where it's like, damn, that's a sick shortcut, and nobody else can see that in the world.
And people are probably looking here and are looking at a lot of math that I don't understand. I only
you know what's funny?
I
this
understand
is
the
one
notation.
of the most mathy paper stuff.
Yeah. Those. I've seen some of your other ones.
Yeah.
Now I understand all the notation here, but I obviously don't understand what's going on because I didn't read it.
These are nice little stuff we learned in quantum optics.
Yeah, this is what the atoms, and this is the light.
That's the field and the
Yeah. So it's like, the more, how would you say this would be gibberish to most people, and most people would get thrown something like this, and they would be like, "Whoa, I could literally never do this."
If your PI throws you this paper off the bat, like as an undergrad without taking
no, but like, I just mean like people get exposure to these things, like especially when they first start out, and they just see these things existing. Because sometimes your PI will give you like a folder of papers and be like, you're going to read this one, but here's the other ones that encompass this work.
Mm-hmm.
And how would you go, like, how do you not get yourself overwhelmed? Like, how do you not be overwhelmed? And how do you, like, get to a point? Because, I mean, I'm seeing people be like, I don't get this at all.
Yeah.
I stick to law guys, and that's okay.
I've only this math, like, once, right?
Yeah.
And even I don't focus on it too much. I think, like, I don't know. I think the biggest thing is, if you can pretend like you're explaining a paper to somebody, that's one of the most helpful things.
Mm-hmm.
Just, like, pretend like you saw this paper, right? And you're just reading, like, the abstract or whatever.
Mm.
And you're just trying to figure out, hey, what can I confidently say to somebody else where I'm not lying and it's something about this paper? Mm. So what you probably start off would be is, like, you know, the paper for stuff like, we propose a new light source, blah, 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 right? And you can kind of just, what I actually like doing for the record is I just kind of, like, read through stuff, and if I don't know a word, I'll just search it up.
Yeah.
Like, really precisely.
No, that's
right?
Yeah.
Like, there's, especially in physics, I think we have this a lot,
Mm-hmm.
where it's, like, some random guy's name, in terms of, like,
Yeah.
a theory or a theory.
They're like using
like, like
Timothy Chalamet's quantum field theory concept.
So
like,
what I'll literally do is I'll, like, in my notes, right, I'll just do a thing called a side. I'll make an open parentheses.
Yeah.
And I'll just search up that theory, and I'll just be like, okay, let me read through this entire theory.
Yeah. So it's kind of like so a lot of times you're like, to approach something like this, you're doing like very, like, it's a slow process, especially in the beginning, where every time you're hitting a new word, you're like, okay, I don't know what ultra narrow clock transition is, and now I'm gonna go look up what that means. I'll be in a tangent for like 10 minutes, figure out what that means, and when I come back to it, I'm like, I understand that now.
Law is cool, by the way. I do like law.
Law is cool.
That's what I was gonna be if not a physicist. Fun fact.
Look at that.
I like law.
But yeah, I think for anyone who aspires to not just do high level like physics research, because this isn't, while initially I want to do a lot of conversations with people I know and they're going to be in physics, we're eventually going to talk to people who aren't just purely in physics, and we're going to have conversations with them about what they do. And in the end, all of their papers, the similar thing, every single one of their papers are going to look confusing, and they're going to look like you're like, I could never do something like that. And I get math is the most in your face kind of, how could I ever do that? But in the end, if you do stick through these things and you keep working at them, eventually these things make sense. I mean, a lot of you probably learned integrals recently that are in the chat, and you probably would have looked at yourself a few years ago and been like, how do people solve something like that? But you figure, like, you just keep kind of keep going, and you figure it out. Like, this stuff, if you get to the point of being able to understand it, it's not too bad. So it's kind of, I think that's a good takeaway to have. And now here, okay, so enough about this paper now. Let's go back to the full cam. Back to full cam. I feel like it's a good discussion to have. How did you get into doing research in the first place? Yeah. What made you want to do research?
That's
oh yeah, let's put this back over here.
Nice.
There.
I did take AP Physics in high school.
I also took AP Physics in high school.
I took AP Physics C. We only had one AP Physics class offered.
I did AP Physics 2 because that was the only one offered for me.
Nice. Oh, not one?
No, not one, just 2. So I just took 2.
Okay, yeah, how to get into research. I kind of figured out, so like, this is like my sophomore year of high school.
Mm-hmm.
I was like, I think I want to do something in science. And then I was like, I don't want to be told what to do. Like, I don't want to just like follow a manual and just do something that somebody else is doing. I'm like, okay, I guess I got to go into like research or something. And then I was like, I kind of like math, I guess, and physics. And also, I had a great physics teacher in high school. Shout out Gastovich, I guess. Yeah. And then, so I was like, okay, my junior year, I was kind of like, I want to do science. I was actually between chemistry and physics, because I really like chemistry too. So
between chem and physics?
Yeah.
Okay.
I like chemistry.
Yeah, there was a question earlier of someone saying, like, what about, like, do you like chemistry? And I was
I like chemistry.
I was like, when I was in high school, I thought I didn't like it. And I was like, I'd rather do physics. But I've gained much more appreciation.
I think chemistry is sick. Like, I don't know. I quite like chemistry. It's also like, you watch Breaking Bad.
True.
Alchemy kind of vibes. Whatever. Yeah, and then 11th grade, I was like, okay, I probably got to figure out, if I want to do this. And I'm like a big believer of like, you should like look into stuff, where you can. Because like, you could say you want to do something, and then people end up in college and they're like, this actually sucks.
So you were in high school and you were like, I think I want to do physics, but I want to do more investigation if I want to do this.
Yeah, exactly.
Okay.
And I think in retrospect too, I probably could have done like any science and just taken it into a PhD. I kind of didn't realize that you could do engineering PhDs at that time either.
Fair.
But I think I still would have picked physics. But effectively, end of my 11th grade, I was like, okay, I gotta like test this theory that I want to do physics research. And I'm like, okay, how does one?
You said 11th grade. Clarify.
End of 11th grade. Yeah.
So you just finished your 11th grade year of high school.
Yeah, exactly.
Okay.
My junior year. And I was like, okay, how does one test the theory of do I like physics research? And I'm like, okay, well, I should do physics research. So we're very fortunate to live close to University of Buffalo, which is an R1 school. It's a nice school. Go Bulls. Yeah, so I kind of like looked at the physics website, and what was cool too is that this other girl in Science Olympiad, which I was also part of, was doing some like random internship thingamajiggy at UB in like biomedical something at UB, right? Yeah. So basically, I knew there was a pathway, or like it existed, that people as high schoolers could like do something at a college.
Yeah. So
I looked through the physics website at University of Buffalo, and I was like, these people look cool. I think I picked a professor because he had lasers in there, and I was like, man, I like lasers. Lasers are cool. And then I reached out to a few people, and one of the guys was like, I'm on sabbatical. I'm not going to be here for a year, so no.
Wait, can we make that clear real quick? You just said that. That's a big point to make. You just said you just finished your junior year of high school.
Yeah.
And then you just went, I feel like learning more about if I want to do physics, so I'm going to go look at this university's website, and I'm just going to email a professor.
Yeah, basically. Yeah, pretty much.
And you can do that.
Yeah. Well, also, it's not even like I was expecting to get anything out of it, right? I was like, at the very least, if I can just talk to these people and just like be a bum, around them for a little bit, I can like kind of gain a little bit of what it's actually like, right? And I'm actually a big believer in that in general. If you want to do a career, you should like, even if you just talk to somebody in the career, it's like super helpful, right? Yeah, so I reached out. This one guy was like, sure, let's try it out. What was cool too is, so they know we're from Buffalo, I assume.
Yeah.
This guy from
I know they know you're from Buffalo.
Oh, I'm also from
we went to undergrad together.
Yeah, that's true.
And then he followed me here. If that's not
actually, fun fact, I got Dario into doing a PhD. I'm just saying that we were like a party or something, and it was boring, or not boring maybe, but like
It was winding down.
It was winding down, and Dario's like, I'm like, so Dario, what do you want to do? And he's like, maybe I'll do like a master's in quantum computing. And I'm like, I don't know if that's the move, buddy.
Yeah.
And then I was like, PhDs are free in terms of if you get into a good school. They're pretty cool.
Do
blah,
that.
Blah, blah, blah. Yeah, exactly.
And I was like, maybe I should look into that.
It's true. No, but yeah, basically, in summary, I reached out to this guy. There's also some guy from Clarence, which is a suburb near Buffalo, who also reached out to this guy. So it was actually two high schoolers meeting with this professor at the same time. In theoretical physics.
You met with another?
Yeah.
So he was a theorist too. Yeah.
But like, throughout my senior year, for the record, I didn't do any productive research my senior year. I was given like this thing called like spin laser papers or whatever, and I got so mind messed up by in like a good way, right? Of like I'm like reading through it and I'm like, what do these words mean, man? Because it was like, a proper research paper, right?
Yeah.
So and I remember the only task they gave me was like recreate this one really simple figure, and it was really just taking an equation and solving it and putting it in Mathematica.
Wait. Let's make sure we clarify the steps here. You reached out to the professor.
Oh yeah. Let me go slow. I reached out to the professor. I met with him. Turns out there's another high schooler there as well, also a senior. And he was like, "Yeah, I'll try this out. I'll waste a bit of time with you two."
And I think the point to make there is that you just blindly reached out to a professor at a university as a high schooler.
Yeah.
And they went, "Sure, come meet with me."
Yeah, exactly.
I think that's very important for.
Well,
I don't think a lot of people understand that.
The
you could
first
do that.
meeting, for the record, was like, "Hey, how serious are you? Are you some guy who like watched PBS Cosmos and it's like, I want to solve the black hole mystery, And I was like, "No, I just kind of want to like try this stuff out." But yeah, so that's true. It was literally just that. And then I set up a meeting. I met with him. Other guys there too. And the professor was nice enough to be like, "I'll waste my time with you two, right? Obviously." In a good way, in terms of like, because there's no guarantee, right? He's just doing it for community development and for physics development or whatever. So he gave us a really simple problem, which is read these papers, plot this thing, which is like basically lasing power to lasing output. Okay.
People don't know what that means, but he's making a graph.
Fine. That's
he's
fine.
making a graph.
You're solving these equations basically, and making a graph, right? But these equations are like part equations, they're partial differential equations.
Yeah.
And I didn't know Mathematica, which is the code he wanted me to use. So for like basically a year, on and off throughout my senior year of high school, where I'm obviously busy with other stuff. I'm not putting as like insane amount of effort into this, right? I'm just like trying to read through these papers and like get some semblance of Mathematica. I remember at one point, so let's say I had two variables, right, A and B. I didn't realize I kept typing them into the Mathematica as A B without a space, and then I'm like, why isn't this working?
Oh, and it just gave you A B as one
as a new variable. Yeah, exactly. Like dumb stuff like that,
Classic
the dumbest stuff
mistake.
ever. But eventually I kind of stuck with it. The other guy kind of like didn't stick with it as much, right? Also through this too, I got a very nice scholarship to UB, because all that kind of fun stuff. And then I stuck with it. I actually got paid going into my freshman year because the guy was like,
college.
College, yes, college year.
So you decided to go to the university then and continue.
At University of Buffalo, exactly, because this was COVID, and I was like, I don't know if I want to go to a city right now. The guy was impressed that I stuck with it. Got paid that summer. Kept doing it 4 years. Got 2 papers out of it. Pretty good time.
So I think it's an important point to make to anyone here. If there's anyone here who's in high school, it's like you very much can reach out to a professor and show genuine interest.
Yeah, I will say. I'll say a caveat here. 2 things. Okay. One, it's easier for professors to kind of entertain you, I should say, as theory, and that's both a good and a bad thing. I did spend a year just trying to get like the basic understanding of being useful, just solving stuff in Mathematica and plotting it and like messing with numericals.
But even just putting in that effort,
I know,
meant a lot.
But that's one caveat, right? It's easier for theoretical professors versus experimentalists. You would have to show up, right? Theoretically, and like actually like turn knobs, and that's kind of like a hard thing for people to do sometimes. It's like let this like below 17-year-old turn knobs in your $100,000 experiment or whatever.
True.
Right. So I will say that's a caveat. So, but yeah, if you're persistent and you want to get something going, I at the very least, people will definitely I think are prone to entertain you in terms of like giving you papers to read and being like, hey, let's just set up meetings and talk about this and see how if you show commitment for a few months, you can get involved or something.
Yeah, and doing even just that in high school, even though you like probably didn't even know what you're doing. Like that in depth, it put you on a very good track of understanding kind of what the field was about, and it gave you. And then as you continue undergrad,
I think more than anything too, it just made me sure that I wanted to do this.
Yeah, and it got you scholarships, and it got you a lot of it got you papers eventually as you kept going, and eventually gets you into good grad school.
I will say one caveat though for the scholarship thing,
Yeah.
and this is I think back to my point of like you shouldn't just turbo focus because I feel like a lot of people in STEM do this a lot.
Mm.
And they're like, see these get degrees, just read do the stuff and it's whatever, right? I think there is some value to being well rounded as like a person, right?
Mm.
Like I got the scholarship for the record, so I had to get interviewed. It was like a full ride scholarship at UB,
Yeah.
right? And they didn't have any physics professors because the physics department is kind of small.
Mm.
So they gave me a history professor because I liked history as well.
Huh.
So I just talked about the Gilded Age the entire time.
Oh, really?
And then the guy asked me like what my favorite episode of The Office was and this random ass stuff.
Huh.
Like you know, like I didn't actually demonstrate any of my the recommendations probably helped from the physics stuff I was doing.
Mm.
But the interview was the final barrier, and I got that because I was a well-rounded person and
Yeah.
I like talking to people. But I think there's something to be said about like. I think we have a misconception in physics or in STEM that like stuff like reading and writing and talking don't matter as much.
Yeah.
They
They
very
absolutely
much
matter. Having communication
they-
skills in science
Like
matter
being a good
ton.
writer, being a good talker has helped me a noticeable amount, I would say.
Yeah. Here, there's a good question here. Is there in your experience a genuine sense of rivalry or tension between theoretical and applied physics, or is that more of a perceived or exaggerated distinction within the community?
To answer that question, I'd say so at our college, right? CU.
Yeah.
It's very collaborative. I wouldn't say so. I'm sure there are. Like let's be honest here, right? I know theorists who are like the Lorentz invariance is not correct here. How dare they? This kind of thing. And there's experimentalists who are like, what is the point of this? This is all on paper, like whatever. There probably are people like that, but in practicality, it's an ecosystem where you can't really have one without the other, right?
Yeah.
Ultimately, it's true. Science is empirical, so the experiment, in my opinion, is the final arbitrator, right?
Yeah.
Like, I don't care what you ever written down if there's an experiment, right? And that's kind of the ultimate goal of science. On the other hand, we don't have the money just to try everything out,
Mm.
And like, there's which person would just start randomly like figuring out special relativity from experiments?
Mm.
Like how do you just do that, right? How do you piece together that math and everything?
It's true, unless you're
right?
goated.
Like,
You'd be goated.
unless you have like an Einstein there or whatever, right? Or like superconductivity, right?
Yeah.
Nobody just starts like randomly testing at these very specific things, like
We gotta have something driving you to
exactly. Again, you need a map to actually build the trail, right?
Mm.
And I think that's why that analogy works. Otherwise, you're just gonna be making trails, and you're gonna be like, oh, this is gonna go to the top of that peak right there. I can't continue this trail anymore, and that's just a waste of, I don't know, the gravel or the dirt or whatever you're using the trail.
My answer to that question would be a lot on can be very university dependent
Yep.
in what the culture is. Like we can speak on our university, which is CU, and it's pretty collaborative, pretty open. So there's not really that going on here. And to be
I
honest,
also think it's field dependent too in physics.
this is true. No, it is very field
Like
dependent.
high energy physics, I think.
Is super collaborative,
Yeah.
stupidly collaborative.
Yeah. Exactly right, and also, the theorists all are like tunnel vision on CERN, in high
Yeah.
energy physics, because that's their
that's
data.
the place.
Yeah, exactly. Versus like maybe other fields like condensed matter or whatever.
But CERN wouldn't exist without theorists being like, you should build this, because you have to justify billions of dollars in spending.
Yeah.
To do something like
Well,
that.
yeah, I mean, like the whole like U.S. quantum or atomic system came together because Einstein wrote a letter to FDR.
Yeah.
To a certain extent, right?
So I think that makes sense. But yeah, I think that's a very good insight into kind of your research and what you're doing. Does anyone have questions for Krish or on a theoretical physicist, and kind of what anything's like?
I've seen the same thing around in theoretical physics. Is pursuing HEP worth it? Oh, that's a good question. Honestly, Natalie or Jared would be better people to answer.
Yeah,
that.
we should have him on at some point. I should definitely have him on.
I will say this. So like my research right now is like quantum information related, right? Or these devices related. So I will say with the current situation going on with science funding, I'm comparatively better insulated from a lot of the stuff because like my stuff has like more clear applications in the near term. Does that make sense?
Mm-hmm.
Versus HEP, I think it's tricky. I think you should do a very kind of candid analysis with talking to people in HEP of just like how the funding's going on. I would hope it's still fine, but what I'm trying to get at is it's more likely that somebody is convinced by like, oh, the quantum computer can break through all the encryption of the world, for like funding us by the government or whatever.
Yeah.
Versus like, oh, this HEP thing of finding the grand unified model will help us a few decades from now. It'll be a really big leap for all of humanity. One's easier to convince a congressman than the other.
Yeah.
And I'll put it that way.
Yeah. No, I think that's very fair. I mean, I will definitely.
But it is a really cool field, and it's super like that's kind of where physics got its start, right?
Yeah.
Like all of those famous nuclear physicists, quantum physicists were all HEP theorists theoretically.
Yeah. I will have some high energy people on at some point one of these weeks, so we will be able to talk to them
what's
about
Gauss's law?
that. Gauss's law is a law made by Gauss. How long does it take to develop a working model or simulations? Like how, like, it basically saying like how long does it take you to develop like one of these papers?
This is where I'm kind of getting at with the learning curve thing, right?
Yeah.
Higher learning curve, where I think, give me those like maybe 6 months and I'll finally get like proper intuition, I'd say. And I'm just ending my first year right now. Right?
Yeah.
But once I'm up there, like for example, some of the senior grad students in my group, right?
Yeah.
They could probably like come up with an idea for a paper in like a few hours, because they just have that level of intuition.
And then fleshing
and
out
then
the
flesh
whole
out
idea
over like a month or two.
Okay.
Right.
So yeah, I think that's probably a good way to put it. Is like if you're new in a field of theory, then it could take. It takes a while to get 2 years even.
Yeah.
To be able to get something at a good enough foundation where you can do something with it. But then once you get that foundation, now you're talking about the students that are getting ready to graduate.
Yeah, and by foundation I mean intuition, right?
Yeah.
Intuition to like come with new ideas and imagination or whatever.
Yeah.
Right, because that's not just learning stuff. That's learning stuff at a deep enough level where you can like make guesses and fill in the blanks.
Yeah. So that's kind of a probably good way to put it. And then also, then you look at the senior students in your lab, and they have so much intuition in that field. And they have such a good foundation.
Or even your professor, right?
Yeah.
Like my professor Murray.
And
like,
they're pumping out ideas.
Oh yeah.
Like in a couple months.
Like some of my people in my group have like just a document with just ideas, which they think would all lead to papers.
So they have more ideas than they don't have time.
Oh,
yeah.
110%. Yeah.
And that's a good thing to point out.
Yeah. Versus an experiment, right? You could argue that, sure, in the first year you can maybe get a paper out, right, or whatever, because it's there, right? It's there.
Yeah.
It's physical. But what if you're trying to make a whole new experiment?
True.
Right. That's a decent amount of kind of turnover right there.
Yeah, that takes a lot to think through.
And that's why, personally, for the record, I chose theory. Is I like having the freedom of working on multiple things at once and what I want at the time. Versus if you invest $100,000 in an experiment, sucks to suck if you don't like it, man. You're just doing that for a year, I would say, right? Like you gotta spend the money.
Yeah, I mean, usually it's like once you're committed to experiment, it's like you don't.
You gotta see it through.
Like I'm doing something right now where I'm getting parts together.
Like
to
I
buy
could
an
stop a
experiment.
project and just start a new project.
Yeah. See, I can't do that.
Yeah.
It's very much like I'm committed to being like this idea. I'm putting thousands of dollars.
No,
into.
I could go to Murray and be like, I don't like this idea, Murray. This is boring. Give me something else, like kind of thing. Yeah.
Murray, your PI, just so
yes,
people are clear.
Sorry. Yeah.
Murray's your PI. If anyone's new here, also, this is Krish. He's a theoretical physicist, physics student at CU with me, and we're yapping about what goes on in that world. Oh, go Bills too. True, go Bills. Always got to throw that out there.
You gotta get a flag back there.
What do laws of physics have the form they do? Why do they have the form they do in something? Maybe like why does the mathematical construct of them look how they do?
That's a great philosophical question. My answer to that would be I don't know. We don't really know. Ask nature. You know what I mean?
Yeah.
Like we're just measuring nature ultimately, and why nature wants to take that form, goodness knows. Why is a hard question in any science.
You're finding the patterns in nature, and nature made them how they
also,
are.
This is a misconception I want to address in physics, in science too. Science isn't like some like religion. You know what I mean? It's not like it's like this is gonna lead to absolute truth. Science is just probability, right? If I drop a ball enough and it keeps falling down, I can build a model, a scientific model, that says that the ball will drop down. It's never 100%. It's never 100%, but it's about taking bets, right? If the experiment keeps doing the same thing, you can guess that the same thing will happen the next time. But it's never supposed to be like, I believe this, irrespective of what the experiment tells me. It's always just, it's simple nature of like, if I eat the poison berry and I die, then if that guy eats the poison berry, he'll also die. And that's kind of just all it is.
Will quantum computing actually benefit? Is it worth the effort of ethical concerns of privacy also?
That's a good question. You could argue that so like with quantum computing and one big thing that a lot of like governments care about for quantum computing is that so right now all of our encryption is based off this thing called RSA. And it's basically just computers find it really hard to multiply two prime numbers together or divide two prime numbers. One other thing, right? And they find it like stupid hard, right? Where it takes like a years for it to do that.
It's so long that they're not gonna do it.
And the whole point is that quantum computing, and quantum computing isn't supposed to be better for the record. It's supposed to be different, right? It's better at certain tasks.
I'm shaking the camera. When
oh, sorry, my bad.
You're fine.
And that's the whole point, right? So the idea is that for example, for encryption, quantum computing could just break our current encryption methods by doing it like in terms of years and like seconds, right? Is that an ethical thing? It's a good question. You could argue that even though it'll break this encryption, you'll have different quantum-based encryptions that it can't break, kind of thing.
That's what we try to adapt, right? We try to we change our change our encryption.
This is a good question. Just like we had the same thing happen, right? RSA, the current encryption method, wasn't always the encryption method. Before that, was something else, and then something else, right? And as things break, encryption methods, you just come up with a better encryption method.
Yep.
So
that's a good way to put.
I think that's the way of putting it. Of like, it's kind of just continuing of just like, there's always gonna be a struggle with just this zero sum game in a lot of cases between governments of trying to break encryption methods and trying to protect them.
Yep. And I mean the games move together. The cryptology
Yeah.
moves with the breakers,
Yeah.
the hackers who try to
Yeah.
break up those things. And I think there's another important
Is it
point that people don't
possible?
realize with quantum computing. And not that I'm an expert in quantum computing whatsoever, but people will just kind of, I feel like they think of quantum computers as like just computers but better, and they
No,
are
no.
in some ways, but they're very much
No,
like
they're different.
they're really good at solving certain problems better than normal computers, but
It's-
they don't do good at other things.
It's kind of like a good example is like your dog will find a tennis ball really fast, right?
Yeah.
Is your dog smarter than you? No, it's just really good at that task. You
Yeah,
know what I mean? It's just different objectives.
And I think that's a good point to make. It's not quantum computers not just
Will
better at
quantum
everything.
AI speed up climate change? What is quantum AI?
Wait, we can be very blunt about this. That may be the dumbest question I've ever heard in my entire life. You
No,
should
no,
feel
I wanna
bad
know
for
what
it. You want to answer it? You wanna answer
Oh
it?
no, send me a paper. I want to read about quantum AI.
Yeah, go ahead and send it. Go ahead and send about quantum AI.
Why is mathematics so unreasonable effective?
Mathematics is just an extension of logic, right?
Mhm.
Like, like there's this thing called Boolean algebra, which is just are things basically true or false to a certain extent. So I would say mathematics is so effective at describing the universe because you could argue that the universe can be described logically. Does that make sense?
Sure.
So if mathematics is the language of logic, then we're saying that you can describe the universe logically, and that's why it's good at describing the universe.
There's a lot of good philosophical videos out there that break that down in a better way.
Yeah.
I'm
Um,
not a huge philosophy.
Would you say a
philosophy nerd.
PhD in engineering basically teaches you how to solve any problem in that niche?
No.
No. Definitely not. I mean, I feel like the very simple answer is no.
There's people in, for example, like if you're doing an experiment in frequency combs right now.
Yeah.
You could not do experiments just like by default on atom interferometry.
Yeah,
or
like
various other
even
things.
though we're in the
like
same
for example, you don't work on any cold atom stuff.
like we're in this, like think about it like this. I am in the same field as Krish. Now Krish is an let's say talk about the experimentalists in his lab.
Yeah, exactly.
We're in the same field, but we do different things. I can't walk in there
And be useful instantly.
yeah. I can't do that and immediately just know what's going on.
Yeah.
It's a it's very broad, and that's a big thing. What we're trying to do here, so we're trying to give you exposure.
And this is also
to different
something
problems out
to
there.
be said, right? Science doesn't really care about labels.
Yeah.
At a certain point, if you're a physics materials researcher, right, you're kind of almost closer to an average physical chemistry PhD than you are to a high energy theorist. You know what I mean?
Mhm.
Like it's all kind of links together at some point. So no, you can't just get a PhD in electrical engineering and solve any electrical engineering problem. Electrical engineering can re-engineer from RF stuff, right, to like quantum
Yeah,
systems.
I like this question here. Are the constants in nature truly constant? I like that one. That's
You
something we
can
talked
answer it
about.
if you want,
Yeah,
sure.
I can answer that. That's something we talk about actually in my lab. Are the constants in nature truly constant? Because
DC is
we
so nice.
we don't know if they're truly constant. We think they are. There's definitions for constants that we've made that we know that we think are absolute, but there are theories that we're trying to test of things like, is dark matter something that is going to change the fundamental constants in nature? If I put something under the presence of a lot of dark matter, is that going to change fundamental constants? We're trying to test that. That's an experiment that's trying to go on in my lab where we're trying to I can't go into it too much, but we're trying to essentially test general relativity using our experiments, and we want to see
Bro,
if
there's
we
no-
can get fundamental constants to change their values slightly. And there's theories that motivate this experiment that point to being like, if these constants change, the reason for that is dark matter, and then we have proof of detection. So that's kind of on that.
Yeah.
What is okay? Dark matter is basically
There's a ton of calculations we've done that say that the universe is spinning at some rate, and we're like, okay, for the universe to be spinning at this rate, there needs to be this much mass, but we can only see like half that mass. The dark matter is all the mass we cannot see.
I think our internet died for a second. Hold on. Internet. Let's see. I think we can tell the internet died in a second. This
Well,
should.
you want to try googling something?
Huh?
You could try googling something.
I mean, Google Works. I think it's just like
Oh,
spiking, so it's just not enough bit rate right now.
God damn it, Aaron.
Maintain smooth streaming. Yeah. You can hear me, guys. Just 1 second. It'll be back.
Oh, it seems fine.
Oh, it seems fine.
Yeah.
Then I don't know what YouTube is complaining about.
It's schizophrenia.
What terms of intervention?
I don't
What is
know.
that?
I don't know.
It's fine. Okay, cool.
But any other
I think
questions?
Arnav had a question really a while back about funding, which was pretty good, but it's been a while now.
Let's see.
Not the quantum AI thing.
Yeah, how is funding for I don't know if people even fully understand the concept of needing to get funding
Okay.
to do research.
I will say, it is not the best time for physics funding necessarily.
Any research funding.
I was talking to my PI, so we have this big like NASA quantum pathways grant or whatever.
Mm.
And I'm like, so how's funding, Murray? How's it going? That's my PI. And he's like, should be fine as long as NASA's still around. Or, NASA still has a budget. And I'm like, oh, cool. That's nice.
Yeah, hopefully
That's nice.
that happens. Hopefully NASA still has a budget.
But yeah. What's crazy too is NASA is one of the most efficient investments we have as a government. Like we get like $5 back for every buck we put into NASA, whatever.
If guys, if you spam questions, I'm not answering them. Just so you know.
He's so big though. You guys have any?
Do you guys have any advice for someone who is interested?
I'd say studying physics in university in terms of like, do you mean you want to do research or do you just want to do it as a major?
Do you have any advice for someone who's interested?
What
in
lies
studying?
beyond the speed of light?
Like maybe what would you tell someone is a good sign that maybe they want to study physics? And because like I feel like we had a lot of experiences when we talked to people entering physics as upper level undergrads. They would have a big misconception of physics and what they thought it was, and they'd be like, "Oh, I was really good at high school physics. I'm goated at this."
I think for me personally, I like physics a lot because I just like solving problems.
Mm-hmm.
Like I remember in high school, they brought like a charged rod near a faucet, and the water bends, right?
Mm-hmm.
And I was like, "That's freaking sick! Why does it do that? That's freaking sick! Like what the heck, right?"
Mm-hmm.
Versus there's also the people in physics who are like, they watch like the PBS Cosmos stuff or whatever, right? And they're like, "I want to solve the black hole mystery." And I'm like,
Which, to
cool.
be fair, people do work on.
People do work on, yes.
But I think the big misconception that people have is that they come in and they're like, within my first year of undergrad,
Yeah.
I want to be working on that.
So let me put it this way, right? For example, I remember actually one of the people either a year below me or my year, when they're taking physics 1 and 2, they were like, okay. Oh no, it was a few years below us.
Mhm.
They were like, they were taking physics 1 and 2, honors physics 1 and 2, and they were like, so when do we get to the real physics? And I think the big thing I would say, 2 ways to know, is that you could always just try looking through research. If you just like the idea of solving questions where you don't have any path to, that's a good example of studying physics.
Yeah.
But also, unironically, if you take a first year physics class, not the engineering version, right? If you take it like if it's like a Swan physics right or whatever,
Yeah.
and like it's like properly done in like physics of like first principles, you build to the problem, this kind of thing,
Mhm.
and you enjoy that, then you probably do want to stick with physics. What you should be wary of is you get like, okay, let's be clear, right? Most of the physics 1 and 2 classes are like those engineering ones, which is like solve for this number, right?
Yeah, they can be kind of dumb.
Yeah, and they're kind of
Yeah.
dumb. But like so maybe even a good way of putting it is that like if you like working on just like physics problems, right?
Mhm.
And building them up from first principles, that's a good thing. What I don't think people should think about is that, oh, I'll get to some year in physics, my 3rd or 4th year, and suddenly it'll be the cool physics. It does get cool, yes. But this idea of you build up a problem from its roots up, I think it's consistent. And I think if you enjoy that, that's a good example of you liking physics.
Yeah. And I think the big thing that scares a lot of people away from physics when they come into it is they come in being like, why am I not doing things on black holes and stuff immediately? Like, where's the physics that I want? And it's like, you're not going to get there for like 4 years minimum.
Yeah, like
And-
properly, right?
yeah, properly.
And again, this is all like what you mean, right? Like you could theoretically like read, like run some code, right, on black holes.
Yeah.
And you could say you're doing black hole research.
Yeah.
But like how much of the code you make yourself, like how much you actually understand it, this kind of thing. Yeah,
Mhm.
I agree. To do proper stuff in depth, I would say, I didn't really, even in my undergraduate research, I don't think I properly understood stuff where I could like start thinking of my own problems until my senior year.
Yeah, that's fair.
Yeah.
And remember, a big thing we're trying to do, this is to, like, to everyone here, a big thing we're trying to do here is talk about like the more human side of science.
Sure.
And like these are two people here doing research in like science on these things, like these weird problems.
That's true. People are saying this.
We're just dudes, you know. We're just
People
dudes.
are saying that.
People,
Yeah.
dudes who
Go off.
yeah, pop off, and like people who do science aren't like just all bots who.
I would hope not.
No, they're like most of
It'd
the
be
time
really
they're not.
boring.
Especially
Actually, I
once
will say there's something you said about like if you're doing a PhD in like a decent school in physics,
yeah.
people are usually pretty interesting.
I was
Yeah.
like I was
Because
really,
you have to just have some kind of discipline, right, to
Yeah.
get there, and then you need hobbies and like personal management of yourself, right? But yeah, like for example, we have a friend Joe who is like really into physics, right? But me and Aaron, our another roommate, went on a hike with him, and he's like, yeah, like he goes on like random like winter backpacking hikes all the time and this kind of thing. He's like a really cool person, you know.
Mhm.
Even if he is incredibly smart in physics.
Yeah, no, I completely agree. Let's see. There was a good question up here on if physics can predict the stock market, which is like not something I know a ton about, but the answer is it can help draw patterns, and it has
the
been
correct
used.
answer is that math can maybe you can make math models that can predict the stock market.
Mhm.
So
But a lot-
physics cannot.
in
Math
a-
models can.
But a good point to make is that there are physicists who have done
right,
that.
but that's because as a physicist you learn enough math
Yeah.
to be a mathematician
Yeah,
to a
yeah.
certain degree. Okay, not a power mathematician. I don't want to like have the field theorist come after me or whatever. But,
yeah, no, the actual mathematicians.
yeah, they're psychotic.
Don't worry.
But like
Not
you do
questionable.
learn a lot of math and physics, and you know by definition, right? And also depends on your field or whatever this
Mhm.
thing. But like yeah, I would say really any PhD you have to know a certain amount of math, but especially physics. Yeah, I mean if you just think about quantum mechanics, right? You need up to partial differential equations,
Yeah.
relativity, general like group theory, all this stuff.
We're getting a lot of like very fundamental questions, which I really
It's
wish.
because you headlined the goddamn stream with theoretical physicists. What do you mean?
I mean, what am I not going to do that?
No,
What am I
of
not-
course.
No, but I get it. No, I get it. I completely get it. What causes gravity to be extremely weak?
There's
Do you
a great
like one?
question. Finally, how do you maintain balance in your lives while putting a lot of effort into your research?
Okay, we'll answer that one.
Okay.
Do you want to? I can start. I can start since you.
Sure.
The way I balance it is, I mean, for me at least in undergrad, it was really busy. Like I was doing work a lot of the time. I really don't want to. I don't want to pretend I had a work-life balance in undergrad. But I think when I got to grad school, I didn't not that great for me.
Oh yeah.
Where I mean, my balance was that all the time I had outside of classes, I put into more work.
Oh,
Or-
I tried to do a lot of fun stuff.
No, that's good. That's why you'll answer next of like how you balance it. I don't think I did a great job in undergrad at balancing things.
Right. Yeah.
In grad school, I think I'm doing a lot better. And how do I balance my life? Is you kind of, I think it's a good way to keep a schedule of what is research life and what is life, and how do you make sure you dedicate some time to both of those. And I think it's easier to do that in grad school, but it's also about the environment you're in. It's important when you're finding labs to join. There's gonna be some labs that are like, I expect you to be here from 9 to 9 p.m. And for me, when I see that, I'm like, okay, that's not a lab I'm gonna join. Simple as that. I'm not gonna join that lab. I'm gonna find a lab that doesn't make me do that.
Yeah. Yeah, so
But,
let me answer that.
yeah.
I also I guess you're right. I just have a distorted view of
No, you're
balance.
fine.
not
No,
like
yeah,
that.
you're good. You're good.
So yeah, me and Dario both would like on the weekdays at the very least, or even all the time, right? So we three of us had very similar schedules, I guess, right? Or two of us had very similar schedules. We did classes, and I skipped ahead a year in classes too, my junior year. So I did my senior year classes, my junior year. We had rocketry,
we made rockets.
and we had physics research, right? So it is correct in terms of time. Perhaps it was not balanced in the sense that like I would come home at like 9 and start doing homework. Probably isn't great, right? In terms of time, it was busy. How do I balance it? I think I've been pretty good about realizing that my career is a really long career, right? You could theoretically, you could do physics, right? Like I have professors I worked with who are in their 80s or whatever, right? Until your brain or your body kind of goes, you can do physics, right? So it's a really long career, and there's no point in burning out early. And I also picked this career because I think it has, in my opinion, a lot of freedom and a lot of flexibility. So I think I've just been pretty good at like just not taking stuff too stressfully, right? Like taking stress where I want. What do I mean by that? I mean, I was perhaps not the best student in terms of my math classes in undergraduate. I don't think I attended a single Calc 3 or Calc 2 class. But it worked out fine, right? Like I still got good grades or whatever. And I think it's just like being able to kind of give yourself leeway to make sure you're not burning out so you can maintain effort for a while is how I balanced it. And for me, that was just choosing my priorities. Even if I got grades, and that's just because maybe I like physics and I'm very invested into it, I chose to put stuff like research and rocketry above my classes to a certain extent, right? And it's, again, not like I had it anywhere close to a C or whatever, right?
Yeah.
But it's like, I still, like, I would, like, be like, okay, am I going to study 2 hours for this problem set or whatever? Or I'm going to be like, we'll try to clutch up for the exam and we'll spend another hour or so, just in the lab hanging out. Or, for the record, so I had a pretty cool group of roommates, too. They were like, I don't know, go out or something, or throw a frisbee around, or drink and play like Mario Kart or whatever, you know what I mean, like this kind of thing. And I think it's just choosing the mental stress of being able to defer things for my kind of mental health.
I think for me, what I
don't
found,
feel well for me, but
I'll just be very brief to move on from the question. Then, I think what I found is that I always felt I was busy, especially in
determination.
science classes. I feel like any STEM student finds themselves to be really busy, but what I did is I forced myself to do that extra thing, and I suddenly found myself having the time to do it because you get better at time managing too.
Yeah. I will also say one other thing. I think I was very good. I'm pretty good about just choosing things I actually believe in, right? Like a lot of people, especially when they're trying to resume build, just like, and I notice a lot of med students specifically, right? They just like pick things because they think it'll look good on their resume, but they don't like care about it, right?
Mm-hmm.
Versus I think everything I basically invested my time into, I actually cared about. So even my volunteer stuff, so I was like a volunteer for the New York election board or whatever, right? And this thing called the Tool Library in Buffalo. Great idea, check it out.
Yeah.
But I like believed in those things. So even when I was doing them, it didn't feel like a drag to me. And I think that's just true of everything, right? Like I believed in physics and doing it. I believed in the rocketry stuff.
Mm.
And in that case, it's not really much of a drag. It's more so just me putting in effort, maybe a bit too much effort, things I actually care about,
Yeah, I think there's an interesting question here. I think
This man was a determination one?
no, this one. I want to be an athlete, but I also really like physics.
Oh.
Do I have time to do both?
Okay.
And I have a good answer in that.
Yeah, go.
Because in undergrad, is that your thing on the
I was
same
thinking of John, and John actually swam for D3 in Genesee.
Oh, I was going to give the undergrad
Okay,
of you can bring up that example after. In undergrad, there was a guy who I met at a conference who went to our undergrad university, but he was the kicker. Yeah, he was the kicker for our football team.
He was a biophysicist.
Yeah, and he was like the number, I think he was like the number 3 kicker in the country. He was like really good.
Really?
No, he was like meeting with like NFL teams.
the APS guy.
Yeah.
Oh, I thought you were talking about the no.
He was really good.
Are you talking about the guy in
Yeah,
our
APS.
classes or the guy we met at APS?
APS.
Oh, okay.
He was also in some of our classes.
Okay, I didn't know.
But he was there. No, there was actually a guy who was meeting with NFL teams to be a kicker at the time, but he was also doing graduate level physics. He was a PhD student in a lab.
Yeah. Also, to answer that question, so there's also a follow up, which is like, is it possible to be a great physicist and a great athlete, or mediocre or both? I think it's hard to be great at multiple things. Personally, you have to do a lot of dedication. Like, if you by great you mean like making it to the major leagues or the Olympics, that's a lot of effort, man.
I think there's always a way to pick two, but like you
can do both, but you might have to pick one over the other.
The way I kind of see it is that you kind of have like your jobs and your hobby, right?
Yeah.
And you can have time to do both, but you
can't do 2 jobs.
Yeah.
Yeah.
But if you can make that other job, if that feels like a hobby to you, then you can get really good at both those things.
Back to the classes thing, right? I picked my job with research and rocketry over classes.
Yeah.
Right, like, okay, my hobby was the classes. That's kind of a weird hobby, but like,
the analogy.
Yeah, exactly.
Is there.
And also, so for the record, to answer that question too, one of my group mates, John, he swam D3 while doing physics, and he's probably one of the smartest people I know, to be honest, just straight up. Very cool person too. But yeah, he swam D3. And from what I understand, there's definitely a bit of burnout. Maybe not burnout, but like there's some pretty brutal schedules, right? I think you wake up at like 6 a.m., swim for like 2 or 3 hours, right, and then do physics or whatever.
Yeah.
So it's pretty brutal, and he's kind of an example of somebody who's, I think, a pretty good swimmer, from what I understand, and actually a really good sailor too. Fun fact. And also
He's a good sailor.
he like went to like some like national sailing competition at some point. He was telling me about.
Damn.
Yeah. But whatever. I digress. A rower or whatever, right? And also a great physicist. But then again, it depends on your definition of greatness, right? Because as much as Genesee was that's the school he went to, it's a New York school, is a great swimming program, one of the best in D3 at the very least. It's still a D3 swimming thing, right? He's not training for the Olympics and also trying to be a great physicist.
Mm-hmm.
But you can. It's just you gotta really muster the effort. And to be frank, being an athlete and a physicist, or being really good at physics, those are kind of 2 big things. So you might not have time for third things,
Yeah,
Like,
but if you really want to do it, like it's not like it's
like I think
impossible.
it would be tough to do like rocketry, physics, and athlete, right? Like Like D3 or like college athletics do take a lot of time. Yeah.
Getting de-romanticized by the mid-20th century isn't going through a breakthrough.
De-romanticized in the mid.
Experimental field. I feel like I don't know exactly how to answer that.
My answer to that would be that in the early 20th century, we had a lot of theoretical breakthroughs, and they were kind of realized over the course of the latter half of the 20th century. So if you mean de-romanticized, and the fact that you're not viewing a bunch of, you don't have some Einstein in your brain right nowadays, sure. I think it's kind of like a byproduct of success, though. A lot of physicists did really cool stuff. Really cool theory came out of it. So now we have more physicists and more cool stuff going on, but there's so much cool stuff, it's kind of hard to focus on just one. So it's not as romantic, right? You think of romantic things as like one story or one person or whatever, and that's less common.
Yeah. Blueberry. I don't know how to answer that. I don't think either of us know how to answer that. FYI.
I want to know your opinion, dude. Yeah, I don't know what the G means.
We don't know how to answer that. How important is sleep and recovery as a PhD student? I mean, very. Right.
Yeah.
I mean, you should.
So, turns out it's physics, especially like the learning of the physics is kind of pretty hard.
Yeah.
And it's hard to do when I'm tired.
Weird that you need brain power for that. Actually,
yeah, it is. And this is one thing which is nice too about my lab. Like, it's like some days I'm in there and I'm like, man, I'm cooked. I was out late last night. I'm cooked. I'm gonna call it a day, come back home, and just work on some random like hands-on stuff. You know what I mean? So especially for learning, I think it's really important to get good sleep. Right? Your brain just won't work. Like, I can tell my brain's just at occupancy, and I'm like, that's it for today.
Yeah. No, absolutely. Is there anything really like? I don't know how to answer that. I'm sorry.
Please discuss the socioeconomic. Oh, I don't know. I mean, economically, probably won't be great for the trade routes.
You're crazy.
Political governments.
You so crazy. That's the socio. You so crazy.
What do you cover up in your masters?
Yeah, yeah. There's a lot of there's a lot of like politics.
We're doing
science and stuff in general.
That's the same guy, right? We're doing really cool stuff, but not in the 20th century. There were a lot of breakthroughs. Every little. Okay, yeah, but I think that's just a matter of just like what sites you're on, right? Like. All of those articles. This is a question from Insomniac Enthusiast, which maybe that guy needs more sleep. But if you're on like a lot of like mainstream, what are you trying to search up?
No, don't worry about it. Keep on.
Mainstream media sites, and they're like, scientists break time, and it's like, what does that even mean, man? I've rambled there. I understand it feels like that, but I think there are a lot of really cool things that we've learned in the past few decades. I mean, like quantum entanglement's a good example. It was only proved in experiment, I think, in the 70s or 80s, I believe. And there's a bunch of applications there. I think it's just a matter of you have a big theoretical breakthrough, and we're kind of seeing it all flesh out right now. There was a new particle discovered in 2014, for example, or 2012 with the Higgs boson. I think there's just more cool stuff, so it's hard to make as much of a big deal as one big major breakthrough. Oh, that makes sense. Oh, green apple, nice. Visualization. How important is the visualize stuff?
Very.
I will also say, I don't think there's a set procedure. I really hate those videos which are like, this is how you think like Einstein, and it's like, what the hell does that even mean, man? Different physicists have different ways of visualizing and looking through problems. Feynman famously would start and just like add little like things to his toy model in his head, like additional factors, and that's kind of how I think of physics too. Is I'm like, okay, I'm visualizing something, and then I add one level of difficulty, and then one more, and one more, and one more.
I want to say it's even more important to have these visualizations to teach other people, not just like you in your field, like getting other people to understand what you're doing. These models and these visualizations and these analogies are extremely important to get other people to see your idea.
They're a good hallmark of intuition, right? Like if you can make an analogy of something, I think you understand a lot better.
Yeah.
Right, because then you understand the core features of it. What do you mean by hidden variable? Do you mean like probability stuff, dude, or do you mean like, hidden variable entanglement? No,
I can't. I don't know how to answer that. Here, we're gonna do a quick sidetrack to end it off with you.
Oh sure.
We're playing.
Great timing.
Let's play a game. Let's see who wins this.
Well, I feel like you played this game before.
No, I haven't. I just pulled up a random one. I was looking for a different one. There was a different one that I wanted to play, and I couldn't find it.
Okay.
So now we're gonna play this against each other.
Okay.
Can you guys hear it?
Twoplayergames.org.
Bro, search up 2-player games. That's crazy.
I did search it up. Hold on. I think I gotta turn this like one volume, and then go desktop audio. Hold on. And then change the source.
I saw a video that says Neil deGrasse Orbital on Doomsday. And what?
Yeah, we don't need volume. It's fine. We're gonna play 2-player.
But,
I think I use this. Oh, you use W. I use up arrow.
Okay. What am I doing? Oh, W and up. W.
Yeah, we just use scores.
Oh, mother. Wait, can I not like go to the side?
Yeah. Whoever wins, their field is better.
Oh, wait, can I not? Can you not? How are you moving to the left and right?
I don't know. I'm just figuring. Oh no, I'm behind the ball now. Oh, I think you have to use your foot. Like you have to use like it's just move. No, don't go. I'm gonna hit it in a minute. Come on, get behind it. No, hit it. It's out. It's out. Come on.
Oh no!
Get out here.
Oh, no! What a save! What a save, actually. Oh
no! One more. Hold on,
no,
we
you've
can
been
full
sauced.
screen.
You've been sauced.
No, I got it.
You've
I
been
got
sauced. Which guy am I? This guy. Why is this so laggy now, man?
it. I full screened it. Doesn't matter.
That was a
1-1. 1-1. 1-1, dude.
No, I won.
1-1. Okay.
How have you going to the left and right? I don't understand.
You have to. Oh!
Sick. 2-1.
No, you have to use the angle your
It
thing's
was a
at.
best of 3.
The angle your thing's at, and then it projects you.
Here, I'll do one more just to rub this.
What do you mean? No, it's gonna end the
Oh.
game. No, it'll end the game at a certain score. It'll end the game at a
You're
certain
getting
score.
fried, man.
No, I'm gonna come back here. I'm gonna come back here.
Yeah. Oh, I'm propelling my guy forward.
No!
That was a brilliant play. That was amazing.
I'm getting killed.
That was arguably the best play ever.
I'm getting killed
Dude,
right now.
Look at that tactic. I jumped
So I'm
up.
trying to go back in the net. I gotta
You're
play a
like
little defense
sheer-
here. Look at that. Look at that.
Okay, ready?
Boom.
Oh, wait. No. I'm a 4.
Come back. No, I'm coming back. I'm coming back now. I'm coming back.
I don't
Now we
think
come
the game
back.
will end for the record.
Now we're coming back. No, it will. You just don't get it. You see how good that was? That was bar down.
That was pretty good, actually. That was a nice top bar.
Oh, football. We got a football now?
Okay, how are you kicking? I don't understand.
Yeah, I don't know either.
You-
But it's
One
tied.
second.
No, you can't use mine.
One second.
It's just the up arrow.
Wait.
Oh no, I'm behind it.
Oh, nice.
No.
Nice.
Ah.
I feel like best of 9 is usually what the. Oh wow.
Get ready for a hard day. Gotta get ready for a hard day of unemployment tomorrow. These physicists. Oh wait, did you win? Oh no! All right,
right.
well, we played one of those.
Yeah.
Good game. All right, everybody. This is everybody. Give a
Arnav.
thank you.
Arnav, I'm pretty sure. How's your stipend coming along, Arnav? How's unemployment?
Yeah, we'll
going?
clown on you. We'll clown on
We'll
you.
clown on you later.
But thank you everybody for or I should say everyone thank Krish. I'll be on for a second longer, but everyone say thank you to Krish for coming in and giving his piece on theoretical physics. I'm sure since we live in the same house, I'm sure he'll be back at some point, but I hope everyone learned something from a lot of this.
Yeah, thanks for the questions. Appreciate it. Some interesting questions. But yeah. All right, cool. I'll leave you to it then.
Sounds good.
I'll let you
dude.
do your AC.
Oh wait, take the chair.
I'm good.
No, take the chair.
I'm good.
Take the chair. No, take the chair. Take the chair. No, take the chair. You gotta take the chair. Take the fucking chair. I think he took the chair. We didn't see you guys. Oh, we forgot to kiss. Damn it. Ugh. No. Ugh. Oh, what? I can't believe I forgot that part. Oh, God. So stupid. I won't forget that next time. I promise. Promise I won't forget that. But yeah. Did everyone, did we all learn something? Today? We enjoy hearing about how theoretical physics works and some of the work being done in there. I hope everybody enjoyed that segment. We'll see what we do next week, but I think that was very beneficial for everyone here. Yeah. If anyone has other questions for me, I can Q&A for a little bit, a wee bit. You learn it. Who's better at kicking balls? Listen, I'm gonna get better at that. I'm gonna redeem myself at some point. I will redeem myself. I spent too much time thinking about golf balls. That the second I got a different kind of ball in front of me, I couldn't lock in at that. It was hard to lock in. Join the middle. Yeah. The VOD will be up. I think next time, I mentioned other people here. I think next time I'm going to try to get this going on Twitch too. Try to dual stream it. I had it like half set up before the stream started, but I just wasn't able to get it going in time. So I was like, we'll save it for next time. But that's my goal. We'll see if that happens. But I'm happy to Q&A for a minute longer. Just yap for a minute before getting going. But that was the extent of the main part of what we wanted to cover today. If anyone has any questions about life or if what's going on, I'm looking forward to getting a new room and a new background, because as you see there, the background right now consists of nothing. But I'm moving into a new place in like a couple weeks, and when that happens, I will be decorating the background extensively. I'm gonna decorate extensively, so then we have better things to look at in the background. Am I Greek in any way? No. I'm Italian. I am Italian. Any random advice on making the most of my final summer before my PhD starts? Try to just do something that you want to do that you think you're not gonna have time for again. If you're moving towns to do it, capitalize on being in your hometown or being in the town you're in right now. That's what I would say. You wanna make as much use of that as possible. But also, yeah. How do you manage your meals? I meal prep, because it's especially during the year it gets busy. Right now, I've been doing a lot of seasoned beef, rice, and broccoli because gotta get the bulk up. But essentially, yeah, meal prep. I try to meal. I like on the weekends. I'll meal prep. I'll make a ton of food. I get like a ton of Tupperware. Tupperware is goated, and then I will. Is there any way to contact me? Join the Discord server. Join the Discord server for sure. The link is in the bio. It's in my bio. Sub if you haven't. Sub if you haven't subscribed to the channel. You made it this far. You need quantum deodorant? Excuse me, sir. Oh, I kind of do. Oh no. I do need quantum deodorant. Sorry, I was just getting so into that. It was just such an interesting discussion to have. I just couldn't help it. I couldn't help but just get so wrapped in it. So just, God, physics. Ugh. Wait till we can talk about golf balls again, but what are your goals this year in terms of content and research? Content-wise, I want to get better. I'm kind of liking, I feel like today, can I get your guys' honest opinions? Like, what do you think went well today with this kind of discussion with a researcher? Like, what are the things that you enjoyed about it? If you have criticisms of things different that you would want to see, tell me. I want to get better at doing stuff like that. That's a goal of mine. A goal of mine is to be able to introduce you more to scientists and show you the more human side of science, because I think that's a big problem that we have right now, where people aren't understanding, like they just kind of see research come out and just like says, scientists figured out this thing, and it's like, okay, who are these scientists? And then you go talk to them and they're just dudes. They're like, yeah, I kind of work on this, and then in my free time, I do cave diving. And you're like, what? And you do physics and you're building these things? So it's kind of, I want to show that other side of these things, and I want to be able to get better at that. So yeah, please tell me the things you liked. Please tell me the things that you think can be done better. I want criticism. And if you want to give me that criticism, and feel free to, if you haven't joined the Discord link is in the bio, join that. And I'm always looking at that Discord, and if you have anything that you want to, like content ideas or things you want to talk about, do that. But other content, I want to get a little bit more efficient at putting out content. It takes me a little longer than I'd like to put a video together. So I want to get a little bit more efficient at that. That'd be the goal. And also just grow in general. The more that we grow here, the more things that I can do and the bigger things that I can do. So we're very much just kind of doing what we can with a $0 budget, but we're going to try to get better at this. We're going to, like, this community is going to grow and we're going to get better. I'm confident. It's just a matter of time. It's literally just a matter of time. So are you a quantum physicist or what? I'm going to do quantum stuff. I'm an experimentalist in atomic, molecular, and optical physics is the best way I can describe it. That's definitely the best way. But do you have a PhD? I don't have my PhD yet. I'm a PhD student. I'm working towards getting mine. I am 22 years old. So, no. I'm working towards mine right now. What is... Rotato, chill. What is your IQ? I don't know. So do you work on optical tweezers and optical cavities? I don't work on that specifically. No, I know people who do. I don't. I work with, it seems like you know what you're talking about. So I work with frequency combs. That's the thing that my lab does. I work on applications of frequency combs. Is this the end of the stream? Well, yeah, we're nearing the end of the stream here. We're just doing a little yapping before I head off. So I'm happy to answer questions, talk about things. You should live stream more often. This was good. Yeah, I'm glad it was good. If I can think of better ideas of things to just talk about, I'm happy to just turn on the camera and just have chats. Because it's like this right here, this is so easy. This is literally just turn on the camera and I'm just talking. And you guys are talking about things and I'm talking back. So I'm happy to do this more. It's hard, like if I was in the gaming niche of things, then it would be like, oh, I'm gonna play this game today, and it's much easier to do that more consistently, longer periods of time. But I'm more in a more education kind of related thing, and I don't think there's people that do really much streaming in that kind of space. And it wasn't something I originally came in being like, I'm gonna do this, but I realized that there's a big hole that I could fill here in giving decent content in conversation in science. So that's kind of what I'm trying to do here. But I'm down to play games. I'm down to do other shit. So it's like, if people are interested in things, tell me. Leave a comment. Tell me things. Send me a message. Tell me, like, I'd really love if you could do this. I'll do it. RF related research. Yeah, there is a lot of RF stuff in my research. For sure. My specific project, not that much. I mean, I do like RF signal processing and some stuff like that. Do we know calling manager Python? Yes, I do. I do know Python very well. But yeah, I forgot what I was saying. But anyways, there's such a stark contrast between electromagnetism and particle physics in terms of difficulty. Yeah, I mean, I think they're each their own beast, and we'll have particle physicists on here at some point, and we'll get to actually ask them what their stuff is like. So that's something for the future. We'll actually have conversations with people who are working to get their PhD in particle physics, and we'll see what they think. No, I don't know much machine learning. Just finished my bachelor's in engineering physics, and I'm going for master's in theoretical physics. Nice, dude. Dude, I have a degree in engineering physics. Fist bump. Engineering physics, bros. I got a degree in engineering physics, too. I did engineering physics and also electrical engineering. Those are my degrees. But the way it worked in my school is I essentially did... physics and engineering physics. But the way my engineering physics degree worked, it was mostly just... It was all of a physics degree and like 85% of an EE degree. So I just gotta tell people I know EE and physics. That's the simplest way to describe it. You are awesome. Thank you. You're awesome for tuning in. You're awesome for supporting. All of you are awesome for supporting. I can't do any of this without any of you who click the button and sit here and watch during your day. So you're all awesome. I'm looking you guys right in the eye. You are awesome. Thank you. Genuinely. What are you most excited for in my field? Good question. I'm probably most excited for... I think there's a lot of really cool applications that you can do with frequency combs. And I'm excited to explore those options. It's a hard question, I guess, to ask. And I probably one I haven't thought about too much. So I gotta think about that more. Like, what am I most excited for? I'm excited for a lot of things. I just think there's a lot of cool research being done. And every single day, I learn about a new someone. I talk to someone new, and I hear about their research, and I'm just like, what? Someone's doing that? I can't believe it. And then I'm like, wow, that's such a cool problem that someone's trying to solve. I didn't even know that existed. And now that's what I want to do to you. I want to introduce you to some of the problems I didn't know existed. I'm subscribing to you, bro. Appreciate that. Thank you. What are you currently working on? Good question. I am currently working on doing... What's the simplest way to describe this? I am working on designing an optical system that includes an optical telescope, which I am pointing at right now the sun and soon to be more distant stars, and I'm measuring the solar spectrum from them to look at what are called Fraunhofer lines, or you can kind of think of that as just spectral features, like features in a black body spectrum that you can pick out that happen because of absorption of certain wavelengths of light in the outer atmosphere of stars as that light travels towards the Earth. And if you can measure those very, very precisely, then you can improve the models of solar activity on the surfaces of stars. And what you can do with that is then you can hand that data off to astronomers who can build these better models, and then they can use that for a method called the radial velocity method for identifying exoplanets. And they can use the radial velocity method, which is essentially as this is my sun, this is my planet, and as the planet goes around, they're going to have a little bit of push and pull on each other, which is going to create this red shift and blue shift in light. And you can, if you can filter out the noise, which is the solar activity on stars, more, then you can identify smaller planets. And we're trying to get down to a point where we can identify Earth-sized planets and be able to try to identify exoplanets and find Earth 2.0. So my contribution to that thing is that my current exact project I'm trying to work on is to design a system to take better, more precise measurements of these solar lines on stars and be able to hand that data off to astronomers so they can improve their models. So I'm building the instrumentation to be able to collect these precision measurements. My field is called optical and quantum metrology. What do you think is more mathematically heavy, astronomy or cosmology? I mean, they're both their own beast in their own way. No real opinion in that. No real perfect opinion. Are you going to college, and is this your last year? I went to college. I graduated undergrad, and I'm in school for a PhD program now. That's what I'm doing now. Are you taking classes while doing research? Yes, in a PhD program, especially in the beginning, you earn your master's along the way to getting your PhD. So while I'm in a PhD program, I'm a PhD student, I'm still doing everything a master's student would do, and I'm also doing research with that. So yes, I'm currently still since I just finished my first year, I'm still working on my classes, and I'll be taking more classes in the fall. Is calculus harder or easier? Comparison to what? But yeah. It's, doing research in the summer is really fun. I can't wait to get to the point where I am done with classes because I want to just do research. I hate the classes. I hate the classes part. I hate the extra things that they make me do. I want to just do research, and yeah, I look forward to when I'm done with classes I can just do it. Because right now in the summer, I just do research full time. I'm a full-time researcher in the summer. So while I'm making these videos, I do research. I go into lab and I do research. But yeah, that's kind of a big thing of what's going on. That's what's popping. Type shit. I want to get that in my vocabulary more. I gotta find more type shit. I gotta find more reasons to use that for no reason. How we can measure stars' radii just by knowing their luminosity and temperature. Yeah. I don't know too much about a lot of that stuff because I'm kind of learning a lot of it for the first time myself. But yeah, it's really fascinating. The more you learn about anything, the more you're like, what? That's how we do that? The more you realize that we're trying to use pulsars to image black holes because we can create a really, really big, basically, telescope with them. Is stupidly cool. Like who came up with that idea? We went let's just use the things in space, and those are gonna be our telescopes. The scientists are absurdly they're insane. And you're like, I can never do that. But then you kind of get into the field, and the more and more you get into it, the more you start being like, I can do that. I can think of something cool. So yeah, it's like, you can totally do something. There are any tensor calculus? You're fine, dude. I didn't do too much of it either. You're fine. If you need it, you need it, and you'll learn it when you need to know it. I probably want to go into astrophysics too. Yeah, go for it. Do it. Astrophysics is sick. Then you should do if you like it, then do it. Motivate you so much as a physics major? I'm glad to give you a little bit of motivation. I just want to show you that it's okay to feel like you're struggling and you have no clue what's going on and you want to drop out, because that's how I feel every day still. Every day I'm like, why am I doing this? But then it's like, it's cool. So it's like, do you believe in a white hole opposed to a black hole? In theory. I mean, a lot of theories like that, those abstract theories, are kind of like, let's make this assumption that this condition doesn't have to hold anymore. Now what could happen if that condition didn't actually have to hold in this situation? And that's how you get to white holes. You take this space-time graph and you kind of go like, what if we can go this way that we normally can't go? And then if you go that way, now all of a sudden you find yourself getting into a white hole. And that's kind of like what happens with that. Where did you study? I went to my undergrad at the University of Buffalo, and right now I'm doing my PhD at the University of Colorado Boulder. My dream job? Doing this. My dream job is doing this. The dream goal is that to keep growing this, keep building a community here, so that when I'm done with my PhD, or even during my PhD, the more this grows, the more I can start incorporating this into my life more and doing more things with this. But then the dream goal will be when this is done, this channel is hopefully grown enough to the point where I can do this full time and do some really awesome things in the world for all of you. Because I'm here to help people. Like, I'm here to help people like you. Like, I'm not doing this for me. I don't give a shit about the money. I don't care. I'm doing this because I think it's cool. And because I want to help people. Like, everyone here, you're all cool. And we're all friends now. And we're gonna do some cool stuff. And all your support that you're giving here is helping me be able to keep doing cool stuff like this. I just want to be able to help people do things. Is there any mathematical proof of room temperature superconductor that can be created? I mean, no, because you can kind of just make a theory for where the cutoff temperature for a lot of these superconductors are, or what the critical temperature would be. But then it's a very material specific property. I don't think you can really make a proof. You can prove that it can be created under what conditions, but then you got to find a material that can actually do it, which doesn't exist at the current moment. If you find one, enjoy your Nobel Prize. That's what I'll say. If you find one, enjoy your Nobel Prize. But, yeah. What else we got? Okay, I'm curious. I need data points here. If everyone had to pick a favorite number between 1 and 10, what is it? We got like 20-something people in here. If you had to pick a favorite number between 1 and 10, what is it? Where's the guy in the thumbnail? His time here is done. So we killed him, and he's gone now. 8, 3. I'm wondering if this is going to be a random distribution or there's going to be some similarities here. 3 1s. 9. I don't think this is. We can make any statistical thing off of this. 7. 7. 7. Okay. Well, 2 7. Wait, you can't just keep saying 7. I will time you out. You keep saying 7, you're about to get timed out. Okay. You have until you hear me say this, and then you're gonna get timed out. Okay, you stopped. Thank you for stopping. But 8. Yeah, I don't think we can draw anything statistical off of that. I was just curious if everyone chose like 1, 2, or 3. That was my curiosity. My favorite number between 1 and 10? 2. I'll tell you why. I'll tell you why my favorite number is 2. Because, SatMech though? SatMech is sick field. Not for me. Super sick field though. The class I took on it was really hard, but I enjoyed it. Will I take the grad class on it? Probably not. But I'm sure I'd learn a lot from it if I did. I just don't want to do it. If you do biophysics, then you'll have to do that, like guaranteed. But my favorite number is 2. And the reason my favorite number is 2 is because when I played sports, I played hockey and soccer and tennis growing up. And when in hockey, I wanted to be the highest number possible. I just really liked high numbers, and you could do 0 through 99. But in hockey, I can't be 99 because Wayne Gretzky is 99, so I can't do 99. So I chose 98, and that was my number. But then when I got later down the line, I was playing soccer in my high school, for my high school team. Then they were like, we only got jerseys between like 1 and like 25 or something. So I was like, I gotta choose a lower number now. So now I'm going to a lower number. And I'm like, what number do I choose? Well, I just did 100 minus 98, and I got 2. And that works out. There you go. My number's 2. That's how I determined that. Thoughts on geophysics course and further opportunities? It's sick. Do it. If you want to do geophysics, do it. Yapping final boss. You saying I'm a yapper? Are you saying like I could sit here all day and just keep finding something to talk about? Is that what you're saying? Are you saying that I could just sit here and I can keep talking about it? Because I can. You're correct. Maybe like, hold on, I want to slightly enlarge this. Nope, not that. It was Alt? Yeah. Boom. There. What grad classes have you taken so far? My first semester, I took graduate quantum mechanics 1, graduate E&M 1, electricity magnetism 1, or electromagnetics. And then my second semester, I took a class on quantum optics, a class on quantum optics and metrology, and then a class on, grad quantum mechanics 2. That's what I've taken so far. Physics of finance is like, it happens all the time. Physics of finance happens all the time. People should realize that. Like, you can't, like, the amount of physics PhDs, like, if I wanted to, I know that when I graduate from my physics PhD, doing research on like optics and all these different things, I can go work in finance if I want to. Did I do anything? Have I ever done anything in finance? No. But they just suck up physicists because they know you can solve problems, you can do math. And then they'll pay you like $300,000 a year. If I wanted it, the option's there. Just throwing it out there. Trying to survive first year physics, so I'm here. Yeah, no, I get that. It will always feel like it's impossible. You just have to know that that's okay, and everyone else is struggling along with me. When I took that, when I was in your position, I struggled, and I was like, do I want to drop out of this? Because I am not doing well. And it's okay. You are okay. You're doing great. You can do it. Can I code? Yes, I can code very well. I've done a lot of coding. In my first year of undergrad, I started out as a computational physics major, so I took all the freshman CS classes, actually. And then I decided I wanted to, instead of taking classes on the CS stuff, I wanted to do electrical engineering stuff. So I kind of I always kept the physics, and I took out the CS stuff, and I put in EE. That was kind of what happened for me. Physics-related cahoots for the community? Dude, that could be a fun idea, something to do. Here, we do a Kahoot night. We just do Kahoots. I just worry about people cheating. It's too easy to cheat in Kahoot. How smart am I? Seriously, I understand that. I'm an idiot. Like, I'm not gonna lie. I'm not that smart. I'm decent at math, but like I'm nowhere near some kind of prodigy or anything. And I'm just a dude who just decided to stick through doing physics. And I feel like the reason I want to share a lot of things with you is because I'm not amazing at all these things. I think I just figured out how to navigate this world and find opportunities and find resources. You don't have to be a genius to do this thing. And that's kind of what I want to share with a lot of you guys, is I want to make sure that you know that you don't have to be super cracked to do something like this. You can just do it. You can find it cool. You can just understand that you're not going to have any clue what you're doing. You're going to struggle the whole time. But if you just keep sticking with it, then you're going to be able to make progress with that. Are you into AIs? Not really fully sure to answer that. You into AIs? Not really completely sure. AI is cool. It's cool. Type shit. Honestly, being someone who does science is far more about being passionate than about actually. Yeah, you just have to be passionate. You have to be passionate to want to go through that. Like, getting any kind of STEM degree is a struggle. It's a struggle. Everyone who's doing a STEM degree had plenty of nights where they're like, they hate themselves. And they're like, I hate that I'm doing this. We got to be passionate about it. You don't got to be a genius. I got to graduation. When I got to my graduation, I would look around the room, and I was like, oh, God, there's so many people here that, like, got here. And I would look around and be like, oh, my God, they made it? Wait, like, he got here? I thought he dropped out. Oh my God, you made it? Congrats! I didn't think you'd get here, but like, I'm joking, obviously. But like, you get what I mean. Like, there's a lot of what do you call it? You gotta just want it. You gotta want it. You gotta just want it. Very clean room, not what you would expect from a STEM major. Thanks. Appreciate that. How you earn? How do I earn? Like, how do I earn money? I'm a PhD student, so I get paid. I'll be very open about my finances here. Because I think it's important for you guys to know. I mean, as a PhD student, all my tuition gets paid, everything like that. And I'm definitely on the higher end of PhD student pay. I make about like 40-something K a year doing my PhD. So that's like money that I get to live life. And I'm perfectly happy with that. I can do whatever I need. Do you feel the same struggle trying to explain what you were studying to friends or family? Yeah. When I told them that I was doing physics and electrical engineering for a while, because like, even just explaining what engineering physics is too much, but I would just say that, and they would look at me and be like, so can you change my lights in my house? They'd be like, can you fix that? And I'm like, no, I don't know how. I'm not an electrician. I don't know. Like, I need a light switch over there. Can you do that? And I'm like, no, I'm not an electrician. I don't know. Like, I don't know how to do that. Like, what do you mean? Like, oh, I also have. I'm trying to get an Ethernet cable upstairs. Can you route a cable from the upstairs and down? I'm like, no, I don't know how to do that. Like, what do you think I do? So yeah, no, So, yeah, definitely hard sometimes. Oh, area of specialization. I do atomic, molecular, and optical physics. I'm an experimentalist. That's what I do. The even more specific, I do metrology, which is the field of precision measurement. Something I didn't think I'd find super cool when I originally looked at it, and now I'm like, there's a lot of cool things you can do with that. A lot of cool things. That's kind of the route. That's kind of that route. Oh my god, we fell off. I'm out of questions. Oh, we got a new question. We're back. We're so back. Favorite scientist? I think Feynman's super cool. I'm a big fan of his ability to explain science in layman's terms. He had a big thing where he would always use very simple language when he explained something. And as someone who wants to be a science communicator, I resonate with that a lot, and that I really appreciate that he breaks things down into a very easy to understand way for anybody, which is a skill in itself. But now we're out of questions again, so we clearly fell off. We clearly completely fell off. Do you work with mass spectroscopy? Spectroscopy, yes. Mass spectroscopy, not fully sure. So, me specifically, no. Maybe someone else in my lab does, but I'm not sure. What have you learned from physics that can be generalized to other aspects of life? I learned that shit just doesn't make sense half the time, and you have to just keep going. Like, you just have to keep trying. Like, shit isn't gonna make sense. It's not. It's gonna be like, research, I would say, even taught me more than I would just say physics. Is that research taught me to be okay not knowing what I'm doing, to feel comfortable being uncomfortable, and that when I do a problem, and I leave the first day of approaching the problem, like, wow, I have no clue what's going on. I've learned to not feel overwhelmed by that, and to feel and understand that's okay. And that translates in other aspects of life. When there's a lot of uncertainty in things in life, I understand that, like, it's okay, and things are gonna figure themselves out. And I have evidence of that, which is from my work. Am I from the UK? No, I'm not from the UK. That's probably a really bad accent. Not from the UK. It's my attempt at a British accent, but it's pretty bad. I can't do it. I need, like, a linguist to get good at that. No. Very much from the US. What do you think of most about? What do you think are the most promising fields of physics to do for a master's for? Like, I would honestly say my field, atomic, molecular, and optical physics. I think there's a lot of good jobs in optical engineering that you can get. But do what you're passionate about. Just do what you're passionate about. I don't fully have a good answer. I know my field pays pretty well, but I also know how it pays. It pays pretty well when you finish a PhD. I'm not fully sure how it works on the master's end of things at the current moment. Tell me about your life as a scientist. It's just, how do I describe my life as a scientist? It's kind of like, I'm just a dude who I go into lab, and every day I have I just kind of keep a to-do list of things that I need to do next. I will go through what I need to do for that day. I'll kind of evaluate, like, based on what I can do. And since a lot of my stuff is measurements with the sun, which you can't see out my window right now because the chat is blocking it, I'll look up the sky and I'll be like, is it sunny today? If it's sunny, then I'm gonna go take measurements with my telescope because I have good data today. And if it's cloudy, I'm gonna be like, okay, today maybe I'll read a paper on something that I want to learn about, and maybe I need to order some parts, so I'm gonna go email companies and try to get quotes for things so I can order things for the future. And usually once a week I'll meet with my advisor. I'll go over with him what I did for the week. He'll give me some direction on where he wants to see me go in the future, and I'll kind of do that. And then I come home, and usually what I'm doing when I get home is I'm working on this stuff. I'm working on making videos and growing this because I'm very passionate about this too. I want to make this work. If you haven't subscribed to the channel, please subscribe. Please support. If you want to join our community, we have a Discord community. The link is in my bio for this stream. Join that community. But yeah. Hobbies outside of physics. Big one right now has definitely been YouTube. I am having a lot of fun making content. I'm having a lot of fun doing this kind of things, interacting with everyone here. It's really cool. I enjoy it. You're all cool. You're all cool. And I appreciate you here. And because of you here, I can keep doing things like this. And I know it's not a big community around. I know it's not. I know it's not like a giant community. I know it's not. We're a small group right now. But I really, really, really believe that that this will work out. I'm confident. I will not stop until this works out. I won't. And you get to be here early and say that you were here early. Because this will work. I promise you. Because I'm stubborn. Subscribe. Thank you. I really appreciate it. Every single one of you that do that. I appreciate it. Do you have an editor or do you edit your videos by yourself? I have a friend who helps me do some editing. I try to do some of the stuff myself when I can, but I'm busy, and I have a friend who's willing to help me do things because he also believes that this will work out if we keep putting in the time. And I'm also always looking for more help and more things to do. If anyone really wants it. But yeah, no. I have a friend who is very nice that he believes in this and is willing to help out because I don't make enough from this that I can pay anybody because I don't really make anything. But I'm not here for the money. But on a side of getting people to help you make content more efficiently, that's where it would help. Favorite physics related series? Dude, I don't know if I have one. I'm bad at watching shows and movies. Give me some if you got recs on shows and movies, just tell me. I'll note them. I need to watch more. Not Veritas. I do love Veritas. I saw the other question. Veritas and Vsauce. Love them. Love them. Oh, more of like a Veritas or Vsauce YouTube fan. I love both of them. I love anything. But yeah. I feel like I was saying something before and I got distracted. I don't remember now. But yeah. Let's see what else we got. What's the end goal for this channel? I would give you a big goal for this channel of something to think about. I think there is a big problem in science communication in that science is getting it's getting defunded in a lot of ways right now. And that issue resonates a lot with me as a scientist, and I feel like a lot of that comes from people not understanding who is doing the science. There's a lack of trust behind these scientists. I'm a scientist. Do I sound like someone that it's like if I told you, like, do I seem untrustworthy to you? Do I seem like I'm just a bot who just does something that someone tells me to do? Like, I don't know. I feel like we can see that, like, we're all people here who have personalities, and I want to kind of bridge that gap, give people more of a human understanding of the people behind science, give you more of an understanding of not just what kind of cool research is being done, because there's a lot of really cool things that you're not even aware of are going on, and I'm not aware too, but I know at least a few more than you know, and I want to show you those. But also show you the more human aspect of science, let's meet the people that do this kind of science and have better discussions with them, and also let's make it fun. I have a lot of just entertaining stuff I want to do. But the more this grows, the more we can branch out and do things, which is why I'm at least starting with doing things like bringing a friend onto a stream so we can talk about it. Don't watch Big Bang Theory. I do like Big Bang Theory, though. I have seen Big Bang Theory. Plenty's anime? Noted. Got it. Noted. What else we got here? What percent of science is useful? It's all useful, and it's just most of it you don't understand is useful until you have deeper conversations about it. And I think an example for me where something I learned about that is what was I doing? Atomic clocks. Atomic clocks are like the cesium clock is what we use to define the second. Define the second. Now you might be like, well, obviously that's useful. We have a definition of the second so we can reference that. But to me, I was like, that sounds still boring to me because it's like, great, we define the second, now what? Like, what are these atomic clocks useful for? And I didn't understand it. And now I've had a lot of conversations with people who do work in this, and I'm understanding that we can use things like atomic clocks to probe for dark matter and test if the fundamental constants in nature are actually constant. And it's getting an understanding of things that I didn't think were useful. And I was like, is that really that useful? And then I had more conversations with people about it, and they were like, no, it's useful. That, to me, that was a big thing. That was huge. I was like, oh, I didn't even realize that there's these use cases for these things. And that to me shows that I think all science is useful science, and a lot of it we just don't understand how useful it is until we talk to the scientists which are working on that. I hope that was a good example. So much science is doing science for science sake. Here's an example to counter that argument. An example to counter that would be, think of particle physics. What does it mean to, why do we care about improving the Standard Model? That's knowledge for knowledge's sake. Same for all of cosmology. Getting an image of a black hole, all knowledge for knowledge's sake. What comes out of that actually matters? Like, what do we get from that as a society? Are we just dumping money into this and we get nothing out of it? Well, this is a question I was wondering until I went to a talk from a very, very well-known particle physicist. And someone asked them that question. They went, why should I give a shit about this? Like, why should I even give any kind of shits about what we're doing? What do I get? And the answer he gave was really, really good and really resonated with me. He went, oh, what we get is the technology that we need to develop to do this science, to get this knowledge for knowledge's sake, is being used by you every day in your life. You don't even realize. I forget the examples he gave me, but he gave some really good examples of, he gave things that like we all use and benefit our everyday life, of things that were developed to solve a problem in a field like particle physics, where it's knowledge for knowledge's sake. So I think that's a very good thing to keep in mind. Is like, yes, this problem, the answer to this direct problem might feel like we get nothing out of it. We don't. Maybe not for like 200 years we're not going to get anything out of that kind of information. But the technology, the engineering, and what we do behind solving that problem, we get a lot out of that. And we don't even really, you have no clue the amount of things that you use in your everyday life that came out of solving problems like that. And I think that's a very important thing to have an understanding of. So that would be my answer to that question. And that when I finally understood that for me opened up a lot of understanding in these different kinds of science and their uses. Because we just might not have a motivation to develop some of that technology otherwise. Like, no one would be like, why is that useful? And then you develop it for this niche problem, and all of a sudden someone else looks at it and they're like, we could use that for this too. And you're like, oh, shit. We could. That'll help a lot of people. And there you go. Fundamental constants, you're trying to prove they're fundamental. The fine structure constant. Fine structure. That was a weird one. It's a weird constant, and there's theories that point under dark matter that its value would move a tiny bit. Once again, they're theories, but theories drive experiments. And enough people think that this theory could be true that it's like, hey, why not try to test it? It might be totally wrong. Might be putting all this money into it, and we're just wrong. It's just wrong. But you don't know until you try. That's science. What is the timescale for future that scientists in your field can work on? Super small, like 10 to the minus like 18 or something. It's like stupidly low. 15, I don't remember. Stupid low. Yeah, 1 over 37. Yeah, that one. That's the fine structure. How'd you realize physics was your calling? I didn't. I kind of just thought it was cool. I kind of just watched a lot of YouTube videos when I was in high school, and I was like, this makes no sense. I want to make it make sense. And I kind of started doing physics, and I got hit with that classic realization a lot of people get when they do physics from watching like all these particle physics and like cosmology videos, and then they get into physics and they're just drilling into them like Newton's laws for 2 years and like basic stuff, and you're like, this is not what I signed up for, but I stuck with it. And that's what you kind of have to do in physics. You have to stick with it, and you have to get all the way to the point where you can do the cool stuff. Now I look at you and I'm like, look at this cool stuff I'm doing. You know how many dumb things I had to do to get here? I didn't realize how important all those things were and how many steps there were before that. That's not something I realized. It took me a while, but it's something that you'll figure out in time. How do you pronounce your name? Dario. 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 That's how my family says it because they're Italian. They go like, Dario, what are you doing today? Come eat the pizza. Come on, mangia. Mangia. Last name Tringali. Tringali. Hardest equation was S equals D over T. Yeah. Yep. And then they would have you plot those and be like, there'd be like I bet you can't find the velocity from this. And you're like, whoa, how do you do that? And they're like, take the derivative. And you're like, whoa. Like, if I take the derivative of a position function, I get velocity? What? And they're like, wait for this one. This was going to blow your fucking mind. And you're like, what? What's going to happen? And they're like, take the derivative again. What? What does that do? What do you, I can do it again? Yep. You get what? Acceleration. No! No way! You get acceleration? There's no way. What if I do it again? Nah, it's nothing. You don't really get much. What? But I do it twice, I get 2 really important. Nah, it doesn't really matter if you do it past that. I think the next one's the jerk force. Someone correct me if I'm wrong. Next one's like what, jerk? And if you go like 6, 7, 8 or something, there's something a little bit later that they actually call them snap, crackle, and pop. Which I think is funny. Fun fact. Little tidbit. How did you manage the hardcore math at that level? Struggle at it for a long time. Struggle at it for a long time until eventually it makes a tiny bit of sense. And then you keep struggling some more. I'm always struggling. The math never makes sense to me. It's always hard. You just kind of get to a point where the stuff that's really hard to you, you kind of look back at the other stuff, you're like, wait, that kind of makes sense now. But the stuff you're currently doing, always hard, always makes no sense, always makes you want to drop out. That doesn't change. Acceleration per second, so they lied to you. Yeah. The jerk force. Gotta love the jerk force. Having problems with perturbation and quantum mechanics. Any help? YouTube. YouTube's got some good videos on perturbation stuff. Good perturbation theory. Do you have a standing desk? No. I don't have a standing desk. The fact that you even say I have a standing desk is crazy. Like, why are you just assuming that I have a standing desk? You're just assuming, you're making an assumption. You're like, this guy looks like he has a standing desk. Why do I look like I have a standing desk? Why do I look like I have a standing desk? Maybe I don't have a standing desk. We'll never know. We'll never know if I have a standing desk, because I'm not going to tell you. I don't want to tell you if I have a standing desk. I do whatever I want to do. We'll never know. Do I have a bed? I sleep on the ground. Why would I have a bed? I'm a scientist. You think I sleep? Stupid. So dumb. Physicist equation tier list one day would be entertaining. That's actually not a bad idea. I did have on my list of ideas a math symbol tier list. Just like vibes. Like integral symbol, just vibes. What's my vibe on epsilon? I should say the Greek letters mainly. Like what's my vibe on all of them? Like only just from a physics perspective, what's my vibe? How would I vibe with these letters? How much pain did they cause me? Where do I want to rate them in that tier list? That would be a fun idea for a stream, actually. We could set that up one time. Yeah, we didn't discover sleep yet. We're working on. We're working on some other stuff first. We'll get there. It's on our list. We'll get there eventually. It's just on our list right now. But like, we'll get there. We'll get there. We'll get there. Do you work out? I do work out consistently. Yes. Very important. Oh, it finally caught up. Change my major to math instead of engineering physics. Is that good general? Yeah, I mean, just do what you're passionate in, dude. Things will figure itself out. Do what you're passionate in. Start there. Yeah, a lot of the math can be tedious. I think I hit a critical point in grad school where the math actually also just became hard along with tedious. Who was the theoretical physicist? Mega. I'm sorry. He was here. You're going to check the VOD when I stop. He was here for about an hour. We had a great discussion. It was good old Krish. It was very briefly on the stream. I don't know if you were here for that, but we did have a good discussion. It'll be back. For anyone who wasn't here before, we will check the VOD when it's done. We had a good discussion with theoretical physicist. It starts with a K, Lovis. Christopher with a K. Krish. But we had a discussion earlier. We were just gonna call him Kith now. So it's like he's just Kith. Kith. Did you have a lot of girls in your physics classes? I mean, it's definitely just like unfortunately like all STEM fields, majority dudes. But yeah, I did. But we did. Oh my god, we caught up. Is this the end? Did I fall off? I think we fell off. Oh, new question. Never mind. What are the derivations important? Why are the derivations of important equations different in different books? Because there's different ways you can get to. You should be able to get to the same thing by different routes. I actually had an issue with the paper this at one point where I was going to publish a paper, and I wasn't the one doing the derivation, but they basically derived something, and they came at it from this way. And then the what they call them, the referees for research papers, went like, I don't believe you. Do it another way, and show us that you can get the same thing. And then they came at it. They got here, and then they came at it from this way, and they went and they got here. And they were like, wait a minute. So they went back to a different guy that like helped read, that helped them derive this equation. And they went like, what's going on here? We're not getting the same thing if we go a different way. And then when they went and talked to that guy, then he was like, no, I did it right. I'm not. And they were like, show us your code, because he used like code to derive the equation. And he was like, they were like, show us your code. They were like, show us, prove it, show it to us. And he was like, nope, my code, not showing you. And we were like, then we can't believe you. So then we were like, okay, we got it. We did it this way and got here. He did it this way and got here. Now we need to do it again this way and get here to prove to ourselves that we're right. So then the lab had the students had to go through and do that over the course of a couple months and prove that the other guy was wrong. And then they were able to publish the paper. And I'm on that paper. You cannot read this comment. Too bad. I just did. Fuck you. What software do you do your work on? If you mean like programming software, Python. Do a lot of Python. We got that shit on lock. Type shit. Type shit. Type shit. I gotta stop saying type shit. I'm not gonna stop. But it's funny. But it's funny. Yeah. I think we're... Type shit. Final lectures are pretty good right now. Yeah, they're... Doesn't college revision myself want to dive deeper. I was recommended the Feynman lectures when I started doing my grad level physics. Like, I started doing my grad level quantum mechanics, and they went, now you can watch the Feynman lectures. And I was like, damn. They're good, but I think to like really get a lot out of it, it's like grad level. Why are you guys on my feed? I don't know. But since you're here, click that subscribe button. You're already here. Might as well. I mean, you might as well. Might as well. You're already here. Support the channel. You have a QM test Tuesday, and you only started studying today. You could have started studying months ahead, and you're still cooked. But you know, I'm kidding. You're gonna do great. You're gonna do great. I got sliced and diced in undergrad quantum, but undergrad quantum 1 specifically. I got absolutely. I got cooked. But we bounced back in quantum 2. Why space-time curvature doesn't break reality? Because space and time are dependent on each other, and when one changes, the other accounts for it. And Einstein proved it. You don't sleep? Never. As I said, that's not a bed. But on a real note, though, no, I do sleep. Like, I make sure to get a good amount of sleep because I can't really function to do research without getting proper sleep. I smashed like and destroyed the sub button and annihilated the bell. Thank you. That's exactly... See, that's the energy I want to see here. I want to see everyone copying that message and sending that. Like, I want everyone to be smashing the like button, destroying the... What is that currency? Thank you so much. I really appreciate that. You don't have to do that. I'm not doing this for money. I'm doing this to just help people. You do not need to be sending me any money. I appreciate that. Oh, okay. Got it. Quantum super chat. That's crazy. It's almost like you watched my video, and you knew how much I would hate that. But yeah, I know that's not that much, but like, don't send me money. You don't need to be sending me money. I appreciate it. I appreciate anything, but you don't need to do that. I'm here to help people, and I'd rather take the money from sponsors and big corporations than individuals. But still, thank you. You get one big boom. Boom. Wait, I gotta do it like this. Boom. Oh, either way works. Either way works. Got it. Yeah, I actually never had seen the symbol for rupees. I'm realizing. Like, I never, like, visually seen that in front of me. But now that you said it, I was like, oh, I do know what that is. Do I, why I hate quantum? Yeah. Yeah. Actually, I thought that video was decent. I thought it was a decent, funny video. I think the thumbnail must have not been it. Thought the algo would like it more. I thought it'd be a good original idea. I didn't see anyone making another video on something like that, so I was like, I thought it'd do well. Do I ever get sponsors? I don't take sponsors really, unless I really see something that I feel like would be good to talk about. I have gotten approached like a little bit from like, I don't know, some like AI tool stuff, but I don't really feel like doing it. I'm not gonna just go talk about something that I don't necessarily feel like would be a good thing. You're loving every bit of quitting social media. Hey, that's valid. That's so valid. Hey, good luck on your physics exam. Does your strategy of aiming for a PhD to save money on the master's apply to math? Yeah, any field. Any field for a PhD should be funded. And they should be paying your tuition. They should. Can you give a silent boom? Is that good? I actually wasn't even silent there. I was just yelling so loud it peaked the mic past a point it heard anything. I was screaming. Where am I from? I'm from New York, Buffalo, New York specifically, but I'm living in Colorado right now doing research at University of Colorado Boulder. Do I have to be a TA? I'm not good at teaching. Well, you will have to do plenty of teaching as a PhD student anyways. You're not getting out of that. It's a good thing to get better at. You can say you're not good at it now, and that's okay. Good thing to get good at. It's a good thing to get better at. You might be able to TA. I TA'd my first semester, and then I got RA funding. I got research funding. But can I not see the physicist because he's theoretical? Yeah. Hey guys, everyone, our guest is here today. Come on in. Come on in. Go ahead, take a seat right there. Nice to meet you. What's your name? Nice. Everyone say hi to... Yeah, what kind of research you do? Me too. Oh, no, you can't say that here. No, you can't say that here. No, you can't. No, you... We had to get rid of him. He was saying things you can't say. He's being very mean. Hi, I'm new here. What's going on? Hey, Alan. Nice to meet you. I'm a physicist. I'm a physics PhD student, and I yap about research. The person, our guest who is here, his segment is over when I end the stream. Please watch the VOD, and you can see us talk about theoretical physics. My acoustic, definitely a little bit. But yeah, we had a conversation with the theoretical physicist on kind of his research in the kind of theoretical physics world. I'm an experimentalist, so now we're just yapping. We'll probably end the stream soon, but for now we're just yapping. Did you study string theory? And then if yes, what is it? No, I don't do string theory or anything really close to that. No. But if you're new here, click the sub button. Click the sub button if you're here. Support the channel. If you want to join our community too, link is in the bio. Link is in my bio if you join the Discord community. But all your support means so much. Like, actually, to all you guys. All of you here are helping. Helping to grow this. Helping to make this better. And we're doing some cool stuff. We're going to do some cool stuff. Which college am I doing my PhD? University of Colorado Boulder. Can't find the sub button? Find it. It's okay. I understand. It's okay. What part of physics am I currently studying? I'm doing atomic, molecular, and optical physics. Even more specific than that, I'm in a field called optical metrology, which is precision measurement. Water time. What do you guys think? Do Twitch next time? We'll dual. Do you think? You guys think that's a good idea? We'll dual stream it on Twitch, and then instead of the YouTube chat, we'll put the Twitch chat up here. I think I can even combine it. There's some things that I can use to combine the YouTube and Twitch chat, which might be beneficial for keeping things in order. But it would definitely be good to get verified at least on. I do like YouTube, I do, but why not dual stream it then, right? Right, Mega? Why not at least just do both? Combined is best. Yeah, I would definitely not do just Twitch. I would do dual stream. My only thought was to make it so instead of the YouTube chat here, I would show Twitch chat, but there's also plugins you can use to make it so it just combines both chats together, and we'll just show that. I'm thinking of trying that. You know, it's good to especially since we have enough people, like if we have even just like 30 people watching, which is a lot of people standing in a room with me, but it helps. It's just more ways that people can join. But I'm thinking I'm gonna set something up to combine the chats, and then also just dual stream it on both platforms at the same time, and then we'll combine the platforms, and then people can choose whatever they want. Yeah, I'm using Twitch a lot. I personally use Twitch a lot, just like when I watch stuff. I like to use Twitch. But yeah, it'd also be good to get, like, I'm verified, or not verified, I'm at least monetized on YouTube, but I'm not monetized on Twitch because I just made an account yesterday. So we could at least work our way towards being monetized on Twitch just by dual streaming. Not that we really need it for anything, but it'll probably just be good to get that. I don't know. Future proofing is my opinion. How long am I gonna yap? Seeing how we're nearing 3 hours, I think we're gonna be about done in a minute. So I'm here for any questions you guys got left. Anything you guys got left. Can I do flips? No, I want to do flips. It's on my bucket list of things to learn soon, is learn to do a backflip. Like, I have people tell me that they're just like, you feel like a guy that can just do a backflip. And it makes me so sad to be like, I can't. So I need to know how to do a backflip. I need to. What is a question? Yes, tell me. What do you do after my PhD? Probably likely go into industry. Okay. Optimal. Do this. We're doing this optimally. That's the optimal scenario. But otherwise, go into industry likely, and then consider the route of going back into academia. We'll probably start. Would you post a physics experiment videos on this channel? Maybe, yeah. I mean, that's like I definitely would need to grow a little bit more before being able to do something like that. Be able to get help. Right now, it's like, I'm a full-time student along with doing this. So and when I'm doing everything myself, I have to manage my time properly. And I'm doing the best I can with that. But the more you guys click the sub button and the more that you support the content, the more of those things I'll be able to do. Do all humans see the same color? That's a great question that I've asked before too. I don't know, and I really want to know. So we'll have to invent that vision sharing machine. Would it be crazy if that like my green is your red? That would be crazy. I think that'd be so cool if it worked like that. If like your brain just like made up what they thought stuff was. Am I watching the NBA? Of course I'm gonna go watch the NBA game today. Of course I am. Who you guys got? Anyone who cares about the NBA? Who you got winning? Who you want? Who do you want to win? Go. Yeah, Pacers or OKC? I need to know. Someone's got an opinion. I know someone here's got an opinion. Real Madrid. Yeah, that's actually the answer I kind of expected. What is the... Yeah, it's also kind of the answer I expected, yeah. You know, with the low CMI cooked? Nope, you're in the exact same place as many of us. Pacers. I knew someone had an opinion. Do I fuck with football or soccer? Yeah, I played soccer my entire life growing up. I do. I do enjoy it. FIFA Club World Cup going on right now has actually been really fun to watch. It's been really fun to watch. But yeah, I think we're hitting 3 hours now. I got stuff I gotta get doing. I want to thank all of you for tuning into the stream today. Thank you all. Another stream next weekend. We'll do another stream next weekend, and yeah, we'll try to get another conversation going. We'll try to think of some other stuff to do. If you ever have recommendations, join the Discord and tell me. If you have an idea of something you want to see, a video you want to see made, content you want to see on stream, I'm happy to. Like, we're a community. Let's discuss these things. So yeah, I thank all of you for tuning in on the stream. This was a very successful stream today. Seemed like people really liked it. So we will we'll definitely keep this going. Shoot for another one next weekend. I do know next weekend I'm doing a backpacking trip. So I'm gonna have to figure out when I'm getting back and maybe do like a later Sunday stream. Might be the option we have to do. So stay tuned. We'll figure it out. But yeah, besides that, that's what I got for today. You're all amazing for tuning in. Thank you for sticking through the content. I hope you enjoyed it. If you have criticism, tell me. If you have something that you really liked and you want to see again, tell me. And I appreciate all of you. All right, everybody. I will see you on the flip. The flippity flip. The flippity flip. Bye. Goodbye, everybody. Goodbye. I'm just gonna stand here for a minute and keep saying bye to let everything catch up. Bye. Bye, Bega. Bye, Joshua. Bye, Insomniac Enthusiast. I hope you get some sleep. I don't want to say your name. I'm gonna call it study account. Bye. Bye. Adios, Alex. Bye, Tefe. Bye, Mega again. Bye, Dar home.